Hello. Hi students, am I live? Am I audible? Let me know in the chat box. Hello everybody. Hi, good morning. Yes, Bacha, if you don't know anything about this chapter, I'm going to tell you what is important from this chapter, what is asked in exams, right? This is a very boring chapter. I know if you start reading it from NCERT, right? At this point of time, you're audible, visible, perfect. Perfect. Let us start. Today we're going to do a one shot of hydrocarbons. I'm going to tell you everything that can be asked in your JEE exam, has been asked and has the possibility of being asked. Okay? So we are going to do every reaction mechanisms, right? And what are the reagents? What is important in this chapter? Let us look at that first of all. Okay, let me introduce Radhe Radhe. Hi Yadhu. Hi Pranavasai. Okay. Hi Sivasakti. Yeah, that is my old student. I remember Sivasakti. Hi Anurag. Radhe Radhe. Chalo, let us start. Okay? Let us start with hydrocarbons. First of all, I want you to know what to expect and what to do in this chapter. Okay, what should you expect and what I'm expecting out of you in this chapter? Everybody should have a notebook and a pen with them. Why? Because this is the first chapter of your organic chemistry, which has so many reagents, and all the reagents are very important. Today we are going to talk about all the reagents possible in this chapter and what are their uses, which gives the syn product, which gives the anti-product, right? Those stereochemistry are not given in any of the books, not even in NCERT, not even the help books that you study, right? So what I'm going to tell you here is very important, but how you're going to remember it? First, bring your notebooks with you and bring a pen with you. Very important. Write down the reagents and write down what do they do. Correct? And you have to learn their application. These 3 points are what you're going to study in this chapter. Okay, from this chapter, what is asked? The reagents and the reactions and their applications are the thing that are asked in your exams. But at this session will extend, okay, because we're going to talk about all the reagents. We're going to start with the hydrocarbons, number 1, which is alkanes. Then we're going to watch the reactions of alkenes. Then we're going to do alkynes. And then we're going to do somewhat of your aromatic hydrocarbons. Okay, a very basic introduction is what you see in this chapter. Correct? Now, first of all, introduction of hydrocarbons, very basic slide, which everyone should know because this is the introductory chapter for your organic chemistry. Then you must know that there are 2 types of hydrocarbons. What is hydrocarbons? Anything which is made up of carbon and hydrogen. That is it. Anything which is made up of carbon and hydrogen is your hydrocarbon. I'm going to start from the very basic. Correct? There are aliphatic and aromatic hydrocarbons. What are aliphatic? They can be either saturated, which means what? They have just single bonds between 2 carbons, are called saturated hydrocarbons, otherwise known as alkanes. What are unsaturated? Which have multiple bonds in them. Example, alkene, which has a double bond. Example, alkyne, which has a triple bond, right? And we're going to study the reactions of all these things. What are aromatic hydrocarbons? One second. Sorry about that. What are aromatic hydrocarbons? Whichever has a benzene ring in it, right? Benzene ring or equivalent or its derivatives. What is aromaticity? I will teach you in another session. Right now, we're going to consider benzene as our aromatic compound in this chapter. Correct? Correct? Beta, GOC, I have planned another series for you. It's going to be short videos. People are asking, ma'am, how will you do the GOC in this 2-week challenge? Bacha, there will be short videos, 15-minute each video covering the GOC. For example, what are polar and non-polar solvents? What is aromaticity? How to distinguish between aromatic, anti-aromatic and non-aromatic compound? There's another entire series just dedicated to your GOC. We are going to do that right now. Focus on hydrocarbons, correct? Now, first of all, you see saturated hydrocarbons. What are they? They are alkanes. What are the main points you must know about alkanes? What is the first molecule of your alkane, bacha, it is your CH4 molecule. Methane molecule is the number first alkane. Correct? It has a structure just like this. It has a tetrahedral shape. Everybody should be aware of this. The carbon here is sp3 hybridized. Correct? And what is the bond angle? What is the bond angle here? Who can tell me? The bond angle here is 109 degree 28 minutes, right? What is the bond length? The CC bond length. The CC bond length in saturated hydrocarbons, bacha, is 154 picometer. And what is the CH bond length? Who knows? The CH bond length, the CH bond length in your alkanes, bacha, is your 112 picometers. Everybody should know this thing. Okay? This, and what is the general formula? Many questions are asked directly from here. They will give you many compounds. Okay? And if you know the general formula, you will be able to make out which compound is that. Their general formula is CnH2n plus 2. What does it mean? For example, if the carbon number is 2, then how many hydrogens will be attached to it? The hydrogens will be 2 into 2 plus 2. Correct? So how many hydrogens are there? 2 into 2 is 4 plus 6. So the formula becomes C2H6. So if you see, a compound as C2H6, you know that it is a alkane compound. Okay, so these are some of the basic things that you should know about alkenes. Also, another thing, these are the only compounds, bacha, which are known as paraffins. What is meant by paraffins? Which are not very reactive. They are inert. Why are they not reactive? Because they are very inert compounds. They do not have any multiple bonds to show reactions. Okay, so they show minimum number of reactions, and whatever reactions they show, we are going to study in this chapter. This thing is clear to everybody? Alkane, what is the structure of alkane? What is the hybridization? What is the bond angle? What is the bond length? The next thing is they are inert, comparatively inert molecules, because they do not show many reactions. Correct? Now we're going to dive right into the reagents and the reactions. First of all, we're going to start with the preparation of alkanes. Bacha, all of these things are very rampant in your JEE exam. I'm already telling you, because I've already seen the pattern in JEE, January JEE, right? So all the reactions and reagents from this chapter were the most repeated reagents. I'm again telling you. For example, number first way to make alkane. So number first is we are going to start from alkene. Okay, we have already taken alkene, which is a double bonded compound. The number first method from alkene is by catalytic hydrogenation. What do? You take an alkene. Now, this is the time for you to take out your notebook and write it down. Number first preparatory method. Just do not write preparatory method. Just write alkene plus H2 in presence of catalyst. For example, nickel will give me a alkane. Can everybody see her alkane over here? Okay, so just like this, a alkene will be given. And what kind of addition it is, bacha? This is a cis addition. What does it mean? For example, this is the alkene, CH2, double bond CH2. Okay? Now here what happens? The hydrogens, both of the hydrogens will attack on the same side, right? On the same side, the hydrogens will attack. See, can you see if they're attacking from the below, both of the hydrogens will attack from the below. If they're attacking from above, both of the hydrogens will attack from the above. So this is a syn addition, and in the end, what will happen? This double bond will go away and this kind of compound will be formed. Okay, what is the major takeaway? In catalytic hydrogenation of alkene, this is a syn. It gives you a syn product. Why is this important? For example, if I show you one example over here, the example is somewhat like this: CH3, C double bond C, CH3, right? And here are H and here are H. So if you try to react it with hydrogen in presence of platinum, palladium or nickel, then what will be the product form? A very syn addition will happen and both of the hydrogens will attack from below side. Correct? Everybody understood this? Okay? Now next, again we're talking about alkenes only. Number first method to prepare alkene from alkene was catalytic hydrogenation. Now again the reagent is alkene. Okay? But what are you making with alkene, bacha? What are you making with alkene? What are you making? Okay, first of all, just do not consider this. Okay? Yes. So you took an alkene and now you have changed the reagent to B2H6. Okay, B2H6. Now, bacha, what will happen? Again, bacha, your alkane will be formed just like this. CH3, CH2, CH3. Again, your alkane will be formed and the hydrogens are attached over here and over here. Just forget this part. Correct? So again, bacha, with your B2H6 and CH3COOH, again the addition is a cis addition. Remember this thing. Both of the hydrogens attack from the similar position. Okay? And here also you have to take account of this solvent. Can you see? Here the second solvent given is to you is your acetic acid solvent. Can everybody see? Can everybody see the acetic acid solvent over here? Now what is happening with the acetic? Now if I change the solvent, for example, I took the same alkene, CH2, double bond CH, CH3, and I took again B2H6, right? And here instead of CH3COH, I'm taking, for example, H2O. Okay? For example, I've taken H2O. Now what will be the reaction? Now, bacha, the product will change. Here the product was a simple alkane when you used a CH3COH as solvent. But when you are using a polar solvent, can everybody see? This is a polar protic solvent, right? When you use a polar solvent, then the answer, bacha, will be something like this. CH2, here will be OH, right? Here will be CH2 and here will be CH3. So what has happened? In this case, there is addition of, there is what has been added over here. There are two things added. Here the OH was added and here the H was added. Okay? So here the addition of H2O has taken place as soon as I change the solvent. Can you see? So in your exam, what will they do to confuse you? They will just change these solvents. So you must know the solvent is so much crucial. We are again doing what? We are again, this just solvent has been changed and the product was changed. So the product that you got here was according to the anti-Markovnikov product. Anti-Markovnikov product. What is anti-Markovnikov? Where the OH, this is the bigger ion, right? The OH is the bigger ion, gets added to that carbon which has more number of hydrogens, right? Can you see that this carbon has 2 hydrogens while this carbon has only 1 hydrogen? This has 2 hydrogens, this has 1 hydrogen. So the OH got added on that carbon which had more number of hydrogens, and such an addition is called anti-Markovnikov addition. Okay? So as soon as you change the product, the solvent, the product changes. Everybody is understanding this? Okay? And yes, Yadhu, you are correct, anti-Markovnikov. Similarly, this is what, bacha, mechanism of how this reaction happens. What is the name of this reaction? The name is hydroboration reduction of alkene. Okay? This is called hydroboration reduction. When from the alkene, you are making the alkene. Okay? This is called hydroboration reduction. But when in this case, when I was adding OH and H, when I was adding water molecule instead, this reaction is called hydroboration. Same. This first name remains same, and here hydroboration oxidation is the name. So you must remember these names. If you are just adding 2 hydrogens, it is called hydroboration reduction. If you are adding OH and H, then it is called hydroboration oxidation. Correct? Everybody understood this? Now, what is the mechanism? What is happening? You took a BH3 molecule. Okay? In BH3, you keep replacing 1 hydrogen. For example, at the one point, you replaced 1 hydrogen with this entire group and you got this kind of product. Okay? A cyclic product is formed which is called the 4-membered cyclic transition state. Then what do you do? Then you again replace all of the hydrogens attached to the boron with this alkene, correct? And later on, after CH3COH is given to it, what happens? An alkane product is formed. Okay, this mechanism is not important. You must know the basic steps that are happening. That a cyclic transition state happens. We know that. Okay, all the 3 hydrogens of boron are replaced. All of these things you must know. Okay, next, when I react it with the solvent, after reacting it with the solvent, the alkane is formed for me. Everybody understood this? Yes. Bacha, I will give the PDF. I will give the session PDF. Do not worry about it. Now next. Now we've talked about 2 of the reagents with alkene. Number 1 was catalytic hydrogenation. Everybody remember? The hydrogen were adding in the presence of a catalyst, right? From the same site. Next was hydroboration reduction. What was happening? Again, hydrogens were adding from the same site. Okay? Now what happens if I'm again changing your reagents? Again, I've taken one alkene. Now the reagent with me is a water molecule, H3O plus molecule, which means in the presence of acid, you have taken water. Okay? In your exams, this can be written in many forms. This reagent. So, what is the ultimate meaning behind it? You have to understand that. What is the meaning? Whenever you see water in presence of any acid, so it can be a hydronium ion, because it can again give away H plus, right? It is again H plus in water. Or it can be water in the presence of acids like H2SO4. H2SO4 plus water can be given to you. Okay? Both of these things mean the same thing. What is happening in this case? Again, there is on this double bond with both of these reagents, bacha, what happens? There is addition of OH and H, right? Again, the same addition will happen. But bacha, what happens in case of hydronium ion? I will again explain it to you like this. The given to you was something like this. Something like this was given. 1 second, let me check. Let me check. Yes, something like this was given to you in the question. Okay? Now I want to react it with H plus and H2O. Correct? What will happen? Number first was the addition of hydrogen will happen. Correct? So if I add hydrogen, bacha, for example, if I add hydrogen over here, then where will the positive charge go? So it will become somewhat like this. The positive charge will come here and I've added the hydrogen over here and there was again something like this. Okay? Now what will happen? Can you see a carbocation is formed? Hai na? So whenever there is carbocation formed, there is a possibility of rearrangement. Very, very important. Understand rearrangement. Rearrangement. Okay? In rearrangement, what happens? This is a secondary carbocation. Everybody agrees this is a secondary carbocation. But if carbocation this comes over here, it will become a tertiary carbocation. Can everybody understanding this part? Okay, so I can move it here. But along with this, what is the next thing that could happen? What is the next thing that could happen? That even ring expansion can take place. Remember one more thing, bacha. Ki 5-membered and 6-membered rings are stable. Remember this thing. 5-membered and 6-membered rings are stable. Can you see this is just a 4-membered ring? But it has the ability to open and do ring expansion. Why? Because there is one carbon which has the carbocation on it. Hai na? So what will happen? I will again show you just like this. Can you see that this is a square box forming over here? A square box is forming, right? Now what will happen? Imagine this is a lid of the box. This green line, imagine, is it a lid of the box? What will happen? This lid will open. Okay? If this lid will open, and imagine I'm opening this lid and I'm attacking this lid to here. I'm attacking this lid to here. Okay? What I'm doing, I'm opening this lid and I'm attacking this lid over there. Okay? Now, bacha, what will happen? Now, bacha, what will happen? ठीक है. So can I remove this bond? Can I remove this bond? है ना? So this kind of structure will be formed. So I can form it like this. This is a 5-membered ring is formed now. Can you see a 5-membered ring is formed now? Correct. On one carbon there is a methane group attached. On the other carbon there is another this hydrogen group attached over here. Can everybody see this thing? Now your positive charge comes over here. Everybody can see that? Everybody can see that? ठीक है? ठीक है? Actually, one second. This will come over here. ठीक है? Everybody understood this part? Everybody understood this part? Now what will happen? Now bachcha, what will happen? This is the secondary carbocation. This is the secondary carbocation again formed, but it is a 5-membered ring which is more stable. Correct? Now your OH from here. Now this hydrogen can attack over here and the OH will attach, and the final product form will be somewhat OH will be here and here will be your H product attached. So this is the final product form. Everybody is understanding? As soon as you are changing the reagent, right now I'm attacking the alkene with this reagent. Now what are the key points you need to remember? When you are trying to attack alkene with H plus and H2O, the addition will be of H and OH. On one carbon OH will go, on the another carbon H will go. OH will go on the most stable carbocation formed. Always remember this thing. On the most stable carbocation, this was the most stable. So OH will go on the most stable carbocation and the H will go on the other carbocation. ठीक है? Everybody understood this thing? So this is the product form that I explained to you, 5-membered ring from the 4-membered ring. This is possible only with this reagent. Next reagent that we're going to talk about is again your, I've taken again this kind of alkene only, है ना? A cycloalkane and an alkene. But now the reagent here is this reagent, HgOAc whole twice and NaBH4. What is this reagent called, bachcha? This is called oxymercuration. Oxymercuration-demercuration. Demercuration. What is happening in here? Here again the addition, okay, first of all let us go upward again. The addition here was again a Markovnikov addition. Markovnikov addition. But here rearrangement was possible. Rearrangement was possible. ठीक है? But here what is happening? Again the addition of OH bachcha is again the Markovnikov addition. ठीक है? But here no rearrangement happens. No rearrangement happens. ठीक है? Everybody understood this point? So right now I am telling you about 3 of the reagents to which to the alkene you are adding 2 kinds of reagent, OH and H. ठीक है? ठीक है? I'm again taking one more blank slide. For example, this is the alkene. This is the alkene, and to this alkene you want to add one H ion and the other OH ion. ठीक है? On one side there will be H, on the another carbon there will be OH. What were the reagents to do that? First reagent was your BH3 reagent. Everybody remember? In BH3 what was happening? Markovnikov, I'm writing anti-M was happening, and here also no rearrangement happened. No rearrangement. ठीक है? Here if I change the reagent to H plus and H2O, what was happening? Markovnikov addition and rearrangement. Rearrangement was happening. ठीक है? The next, to add the same kind of things, H on one carbon, OH on the other carbon, if you are using anything of mercury, which is called Oxymercuration-demercuration reaction, in that again the addition was Markovnikov addition. ठीक है? But there was no rearrangement. This is how you are going to make your notes. This is how, bachcha, you are going to make your notes. ठीक है? Yes, bacha, we will keep the mock test at the end after this 2-week series is over. Everybody understood this point? This is very basic, very important points to understand. Okay, now let us do this question, which is a JEE Main 2024 question based on all the things I taught you right now. Products A and B formed in the following set of reaction are. You've been given one alkene. Okay, can everybody see this alkene? And you are trying to react this alkene with number first H plus in H2O and form a A product, and number second with B2H6 H2O2. Can everybody see? Can everybody see here again? H2O2, which is a polar solvent, is added to it and NaOH is added to it. So what will be the product A and what will be the product B? Based on all the things I explained to you. Can anybody answer this question for me? Who can answer this question for me? Who can answer this question for me? I'm looking at the chat box. Please answer. Okay. Who can answer this question for me? I'm looking. What do you think should be the answer? Again, with both of these reagents, what will add? On one double bond. So on the this is a double bonded carbon, right? On one of the carbon, OH will add, and on the other of the carbon, H will add. Okay? So there will be two kinds of addition. Okay, somebody has answered, Prabhu has answered D, Abhishek has answered D, and Gautam Raj has answered B, aspirant is a, hi Shiva, Shiva has answered B. ठीक है. Before I let you know the answer to this, I have another important thing to let you know to you guys, because people are asking, ma'am, how to prepare for this session. So I have a very, very good news for you. Please stay here. Please stay tuned for the good news before knowing the answer. The good news is Vedantu is now live in your city. What does that mean? It means that you can now be a Vedan, be the part of Vedantu, be the part of a family of Vedantu, and you can learn with us in person, right? So we will be standing here and you'll be just in front of us, just like your offline classroom coaching is being provided by Vedantu. After so many students have requested us for offline coaching, we are finally opening up the offline centers, right? And if you are present on any of these cities which is mentioned here, we're now even in Jammu and in Srinagar, we are open right now, correct? And we are in Delhi, Punjab, in Patiala, in Muzaffarpur, in Bhilai, in Raipur, in Bilaspur, in Bhubaneswar, in Hyderabad, in Jhunjhunu, in Vishakhapatnam, Vijayawada, Guntur, Chennai, Coimbatore, Madurai, Trichy, Pondicherry, in Maharashtra, in Pune, Nagpur, Aurangabad. So these are all the cities that we are right now present. If you are from any of these cities or you are near these cities also, you can join the Vedantu offline program. Okay? So you can call now if you want to know more details about it, ma'am, how to book the schedule, how to book an appointment. And if you are a very serious aspirant for your JEE 2025 attempt, right? For the JEE 2025 attempt or even the 2026 attempt, if you are just the 11th standard question, you can either call on this number, right? Or you can just visit the link given in the description box below. Very limited seats are available, obviously, because it is the offline classroom. Not many students can be accommodated. Okay? Shreya sir has already told you, right? So this is the same thing that we are telling, that I'm telling you about. Again, why should you join this? Because bacha, guaranteed improvement in marks or 100% fees refund is what Vedantu is offering. That's, see, we have always done free coaching, right? On YouTube, what we are doing, we're giving you free material to read. So we will obviously do the 100% fee refund if you do not find value if after going to the centers. So this is something that we are offering, and please do check it out, right? You should, even if you're not interested in offline learning, then you should just go once, check it out, take the feel. Why is it important? Because you will be in some schedule, right? You will be in a schedule. You will go somewhere all the day. See, you have somewhere to go every day and then come back, and then you will have notes with you. You'll have so many class tests with you. So it is actually a very good opportunity for you guys. And what are we offering, bacha? For example, for the 12th starting students, if you are, because you are JEE aspirants right now, if you are taking the JEE 2024 attempt, then we are launching a test series for you guys, which starts from 11th March 2024, already started yesterday, right? And if you are 11th moving 12th, and you want to take the JEE exam in 2025 again, then actually the long track weekend crash course start from 23rd March, right? And the long track course, which will be on every day, which will start from 27th March, correct? And 10th moving 11 students can again join our bridge course, which starts from just now 18th March next week. Long track starts from 2nd April, and long track weekend courses, just take the classes on the weekend, weekdays go to school, right? It starts from 6th April. Next, all of these, if you are a even lower grade students, or if your brother, sister, if you know anybody who's a lower grade student, they can again take part in the JEE NEET Foundation courses, which again starts from the 2nd April 2024. Okay? This is what I had to tell you. Now let us look at the answer. People have already given me the answer C, D, C, D, C, D. So, okay, what will happen? Let me again draw the molecule over here. Let me again draw the molecule over here. This was the molecule, right? This was for bacha. More information who are asking, links are in the description box below. Please click on those links and you'll be directed to how to make the appointment with the offline centers, right? Or you can just call on that number and take out more information if you're serious about your JEE preparations. Okay? Now let us get back to this question. So this was the alkene given to you, right? And with H plus and H2O, what will happen? With H plus and H2O, H plus and H2O, right? Which is the most stable carbocation form? Can anybody answer this to me? The most stable carbocation form, if I remove this alkene, will be this carbocation CH3. Here will be the positive charge. This is the tertiary carbocation form. Hence, hydrogen will attach over here. The tertiary carbocation form will be more stable. Hence, the hydrogen will attach over here. Okay, the next thing that will happen, now you have to attack your OH from the water. So now the OH will attack here. So this is the product number A. Okay, this is the product number A. Why? Because this is the most stable carbocation formed, and hence this is the product. Next, your product B, which is B2H6. In B2H6, there is no formation of carbocation, and we know the addition of OH happens to anti-Markovnikov rule. Anti-Markovnikov rule says what? That the OH will attack on that carbon which has maximum number of hydrogens, right? So here the OH will attack and here the H. So this is the B option and this is the A option. Everybody understood this thing? Ma'am, I watched already Diksha Ma'am hydrocarbon. Beta, Diksha Ma'am hydrocarbon is for NEET exam. This is, we are preparing for the JEE exam, right? Right? So the answer is D. Whoever answered D, I have given the correct answer to me. Correct. Next is from alkyne reduction. We have talked, what we are talking about, once again, let's go back. We are talking about the preparation of alkanes. Okay? First of all, we looked how to prepare alkanes from alkenes. What were the reagents from preparation of alkanes to alkenes? There were many reagents. Number first is catalytic hydrogenation. Number 2 was hydroboration. Okay? Number 3, we also saw oxymercuration. The 3 reagents we already saw in the last thing. Now we're talking with alkyne. How to prepare alkanes from alkynes, that is triple bond. Again, the number first method is catalytic hydrogenation. In the presence of catalyst, which is platinum, palladium or nickel, okay, what will happen? First step will be the preparation of an alkene. Can you see here an alkene is prepared? The next thing is, again, what will happen if you raise the temperature, then your alkane will be formed. Okay? Alkane will be formed. And if bacha also remember, a name reaction is here. If for the catalytic hydrogenation, you are using the catalyst nickel. If you are using the catalyst nickel, then your reaction has a name which is called Sabatier-Sanderson reaction. Remember this thing. If in this reaction, instead of platinum and palladium, you have taken the reagent nickel, if you've taken the catalyst nickel, then it is called Sebastian-Sanderson's reaction. If anybody asks you, it is just catalytic hydrogenation. Okay? But this is true only for alkynes. Alkynes. So when you are trying to reduce alkynes, what you are doing? To the alkynes, I'm adding more hydrogens. So this is another kind of hydrogenation reaction, isn't it? Isn't it? This is another kind of hydrogenation because I'm adding hydrogen to it, right? So if to the alkynes nickel is used, then only it is called Sebastian-Sanderson reaction. If to alkenes you are using this, then it is not called Sebastian-Sanderson. Only with alkynes it is called that. ठीक है? ठीक है? Beta, it is syn addition only. This is syn. Do not take it on this. This is again a syn addition. Remember this thing. This is syn. Because how the addition happens with the catalyst, for example, this is a catalyst, right? This is a catalyst, for example, I've taken platinum. On platinum, what will happen? First, the hydrogens will sit down on it and then your alkene will come. Then your, for example, your alkyne will come. So the hydrogens will attack from the same position on the catalyst. This is always a syn addition only. This is again a syn addition. Okay? Just to show you, it was written like an anti-product, but it was a syn product. Okay? The next is, now from alkyl halides, you are trying to prepare alkanes. What are alkyl halides? For example, this is the alkyl halide, right? To the alkyl halide, what you want to do, you want to replace the halogen with hydrogen. Okay? Now, please write down all the reagents. I know in this chapter, there are going to be numerous reactions. But you don't have to remember all the reactions. What you have to remember? The reagent and what do they do. For example, with alkenes, ma'am, I was using, with alkenes, I taught you just 3 reagents. Those 3 reagents, what they were doing. Okay? From alkynes, we again did catalytic hydrogenation. What they were doing. Okay? Next again, by alkyl halides. By alkyl halides, you will replace the halogen with hydrogen. So what you are doing again? You are doing reduction, isn't it? This is a reduction reaction. Why? Because there is addition of hydrogen happening in the product. What is the addition of hydrogen means? It means that you are performing a reduction reaction. So you took an alkyl halide, you replace the this halide with hydrogen in presence of zinc copper couple and ROH molecule. Okay? Now please remember all the reagents by which this reduction can happen. The reagents are zinc copper couple with your alcohol. Okay? Number first reagent. Number second is sodium plus ethanol in presence of sodium and amalgam. Hg is called amalgam. या फिर plus H2O or LiAlH4. So all these things can be used as a reagents. And ma'am, how to remember these reagents? Only after you have written down in their notebook, then only you can remember all these reagents. Looking at here, looking at these notes, you will not remember. When you form your own notes, only and only then you will remember all these reagents. So what are these reagents doing? They're just reducing the alkyl halide to simple alkane. What I'm getting, a simple alkane I'm getting. Okay? Now, bacha, the next thing that is very important is when alkyl halide reacts with sodium. So what did I do? I took a alkyl halide. This is again your Wurtz reaction. Wurtz reaction, which you have already studied in haloalkanes and haloarenes. You study the reaction, right? What happens in Wurtz reaction? You take an alkyl halide, you try to react with sodium, right? And you take another alkyl halide just like this. What happens? This goes away. This goes away and your product RR alkane is formed. Simple, symmetrical alkane. Even number of alkanes. Symmetrical alkanes is formed. This is called Wurtz reaction. This always happens in presence of dry ether. This is again another preparatory method for your alkanes. Okay? Now here a very important note is written that this reaction is not suitable for tertiary Hello. Okay. No, but actually it was coming and in the middle it stopped automatically. Hmm. Working on. In the middle it stopped. But it automatically got switched off.
अच्छा might be वो
when you like keep that thing open, make sure that it's always on.
एक काम करो ना इसको आप ऐसे इधर डाल
ठीक है, okay. Okay. Hi students, we're back. Retake from Wurtz reaction. We're going to do that. We're going to start with the Wurtz reaction once again. I'm sorry for the delay. Sorry about the delay. See, I think the stars are not in my favor. Whenever I take any class, these things are supposed to happen. If you followed me on Vedantu JEE also, so many technical issues happened. Oh my God. Okay, so we were talking about the Wurtz reaction, right? Wurtz reaction, what happens in Wurtz reaction? Okay? Yes, we're starting with the Wurtz reaction, bacha. So what we were doing, again from the alkyl halide only we are preparing alkanes. Number first method to prepare from alkyl halide was this, that you only reduce it with all these reducing reagents. Number second, from the alkyl halide, what do? You do the Wurtz reaction, which is you take in RX halide, okay, and in presence of sodium, you react it with another RX halide. Okay, same halide you're reacting, and what you're doing, you are eliminating this product, and what you're getting is actually a symmetrical even alkane. What are you getting? You are getting a symmetrical even number of alkane. Please remember this thing. You always get a symmetrical product, right? If two are and even numbers, there will not be odd numbers of alkanes possible. Number first thing with the Wurtz reaction, you are getting simple alkane product. Remember one thing, that this reaction is not suitable for tertiary alkyl halides. Okay? It's clear? Okay? It is not suitable for tertiary alkyl halides. If you take a tertiary alkyl halide means what? If you take a alkyl halide like this, if you take a alkyl halide like this is X, and here also R, and here also R. So what you've taken? You've taken a tertiary alkyl halide. Sorry, it will not be like this. One second. Yes, it will be like this. So if you have taken a tertiary alkyl halide like this will not give Wurtz reaction. Remember this thing. This will not give Wurtz reaction. Instead, it will give a alkene and not the Wurtz reaction. Okay? This is the first thing that we talked about. Next thing is, what if, ma'am, I take two different kinds of alkanes? What if I'm taking two different kinds of alkanes? Okay, I'm erasing all this once again and we're teaching once again. What I took two different kinds of alkanes, CH3Br and C2H5Br, which is methyl bromide and ethyl bromide. I took in the presence of sodium. Okay, then what is happening in the presence of sodium? Okay, in the presence of sodium, what will happen? Two kinds of reactions can happen. This can react with itself, CH3Br, right? And it will form a ethane just like this. The other thing is, this C2H5 can react with another C2H5Br and form a butane molecule just like this, isn't it? And a butane molecule can be formed. The third possibility is, this methyl bromide reacts with this ethyl bromide, right? And it will form a CH3, C2H5, which is a propane product. Right? So three kinds of, you will get a mixture of products if you start with mixture of alkyl halides. Remember this thing. So mixture of products are not good for us, right? You are getting a mixture of products which are very difficult to separate. So this is not a good preparatory method to make your alkanes, which is odd number of alkanes. Only in this case you get a odd number of alkanes. Otherwise, with itself, it will always make even number of alkanes. Like this is a 4 number alkane, this is a 2 number alkane, right? Consists of 2 carbons, this consists of 4 carbons, this alone consists of 3 carbons. Okay, clear? Oh, very good. Next, preparatory method of alkane again. Right now, again, I'm going to just make you clear in your head. Number first preparatory method was from alkenes. What all reagents were there from alkenes? Remember. Number second preparatory methods from alkynes. What all reagents were there from alkynes, ma'am? Number third was from alkyl halide. 2 methods from alkyl halide we just studied, right? Number fourth preparatory method of alkane is this, which is decarboxylation of salts of carboxylic acid. What you are doing? You're just taking a carboxylic acid salt like COONA and in the presence of soda lime. What is soda lime? NaOH plus CaO is called soda lime. Okay? Both of these together, bacha, is called a soda lime. Remember this thing? So when you heat RCEONA with soda lime, you actually get a RH product. What you are getting? Beta, from here, the CO2 molecule will go away and you will be left behind with a normal alkane. So whatever number of carbons you started with, you will get one less number of carbon in the product. है ना? Whatever carbons, because one CO2 goes away, right? So whatever number of carbons you're starting with, you get one less number of alkane over here in decarboxylation reaction. This is called decarboxylation because CO2 is going away in the form of Na2CO3. Correct? Similarly, they have given you another example, CH3CONA. You started with 2 number of acid, 2 carbon acid, which is a ethanoic acid, right? But in the end, you are getting just a methane product. Okay? You are getting just a methane product with decarboxylation using soda lime. Correct? The next method is, okay, let us look at the, what is called, this is called the mechanism of that. How do you do that? You had a RCEONA, correct? You started with RCEO minus and Na plus, correct? You started with the sodium salt of acid. So this can be written as RCEO minus, right? And you're trying to react it with the NaOH. What does NaOH give? NaOH, ma'am, gives the OH negative ion. है ना? So it gives the OH negative, which has a negative charge. And do you know that this carboxylate ion, because it is attached to more electronegative oxygen, hence this carbon gets a positive charge, right? So this OH negative will be attached to this COO negative, right? And this is how an addition product is formed. And after this is formed, what happens? Your CEO minus groups goes away and your R minus anion is left. Now to this R minus anion, this H plus attacks and forms your RH compound. This mechanism no one will ask, okay? I do not recommend you to learn this mechanism, but just understand it. Okay? But just in order to understand it. No, bacha, mechanism is not needed. What? The certain things of mechanisms are needed, right? For example, in this, the attack of the OH is happening. This you should know. What is attacking here? OH negative is attacking. So, few of the things you must know. You should not know the entire mechanism. Okay? Next is again Kolbe electrolysis. Very important. Asked so many times in exam. What happens in Kolbe electrolysis? You again take a sodium or potassium salt of the carboxylic acid. You took a sodium or potassium salt like this. Let me just put the mic over here 1 second. You took a sodium or potassium salt just like this, and in the presence of electrolysis. Electrolysis is what? You are giving current. You took the acid in a beaker, for example. You took the acid in a beaker, right? And you put some electrodes in it, and here you have put this acid, which is sodium or potassium salt of carboxylic acid in this beaker, and now you're giving it electricity. Okay, now you're giving it electricity. After giving the electricity, what will be formed? At the anode, remember this thing, at the anode, you will get again a symmetrical even number of carbon chain, alkane chain, just like this. For example, you started with RCOO, this product, and this will go away, and what will happen? This R will react with another molecule of R, and this will also go away, and you will get a RR product at the anode. Remember this thing. This reaction takes place through reduction mechanism. What is happening here, bacha? What is happening? A free radical is forming. You started with RCEO minus, right? And one electron will go away. When one electron goes away, you will be left with a free radical. And whenever free radicals are generated, they react with another free radical and form a alkane product just like this. Okay? Form a alkane product just like this. Oxygen is double bonded. Ma'am, the first diagram is wrong. Which diagram is wrong, bacha? This is wrong. Correct. This will C double bond O. Yes. Sometimes you know what happens when I create this PPT now, when I create it in Google Slides, right? And I'm opening this in Microsoft PowerPoint. So what happens? All these reagents start shifting. Whatever bonds I've made here, they shift here. You will see that happening in so many. But when you get the PDF, you'll get the correct thing. Don't worry about it. Okay? Now, bacha, in Kolbe electrolysis at anode, what is happening? At anode. For example, I started with RCEO minus. Okay? This what I started with, and at the anode, I will get RR product. So this CEO will go away, and this R will join with another R, form a symmetrical alkane, just like this. At cathode, what will happen? At cathode, bacha, what will happen? Hydrogen will be released. So I'm telling you all the basic fundas that you need to know. You do not need to go in the entire mechanism. At cathode, ma'am, hydrogen is released, and at anode, your alkane is formed. So whenever can you see that only here in this method, methane can never be formed. Remember this thing. How can methane be formed? Can methane ever be formed in this reaction? For example, you started even with, if you started even with HCEO minus, if you started even with this formic acid, if you started with this formic acid, after electrolysis, it will form a CH3 kind of product, which is a ethane product. So, with Kolbe electrolysis, methane is never formed. Okay? Another important point. When is methane never formed? In Kolbe electrolysis. Okay? Next question on your screen. Who can answer this for me? Kolbe synthesis of sodium salt of butanoic acid gives. Who can answer this question for me? Yes, but I've attached the mic to caller. Kolbe synthesis, I'm looking at the chat box once again. Answer the question for me. Kolbe synthesis of sodium salt of butanoic acid. You have taken a butanoic acid, which is CH3, CH2, CH2 and COO minus sodium salt of butanoic acid. And you're trying to do the Kolbe electrolysis product. What will be the answer? First answer, Jeevan has given me D, propane. Propane will never be the answer. Jeevan, what are you even studying over here? Abhishek, A. Very good, Abhishek. Roshan, C. No, bacha. Jeevan, A. Jana, A. No. Bacha, in Kolbe electrolysis, what was happening? This free radical was generating, do you remember? After Kolbe electrolysis, CH3, CH2, CH2, free radical is generated. This CO2 goes away. The CO2 goes away, this free radical is generated. This free radical reacts with another similar free radical, CH2, CH3, CH3, CH2, CH3, CH3. Okay? Another free radical is generated. 1 second. Yes. Okay? Now they will join together. What happens? They will now join together. These free radicals join together and form a structure just like this. 1, 2, 3, 4, 5, 6. Normal hexane product is formed. Normal hexane product is formed. Okay? Everybody understood? Okay, Shiva? No. The correct answer is A. Okay? Correct. N-hexane is the correct answer. We have already done this part. Solution. Now we are back to the physical properties. We've done all the preparatory methods. Can you see? We've done all the preparatory methods. Please revise with me so that you do not forget. We started to prepare alkanes, number one with alkenes, right? With alkenes, you prepared with 3 reagents. Try to remember the 3 reagents. Okay? Number second, with your alkynes. What reagents did we use? Number third, from alkyl halides. Number fourth, from your acids. Okay? Sodium salt of carboxylic acid. With again, from that we had again 2 methods, Kolbe's electrolysis, and the another one was soda lime, है ना? So all these preparatory methods were done and dusted with. Now we're talking about the physical properties of alkane. What are the physical properties? The first 4 alkanes, which is C1 to C4, bacha, are your colorless and odorless gases. Remember this thing. C1 to C4 are your gases. The next 13, which is your C5 to C17, are your liquids. Again, colorless and odorless. Okay? And from C18 onwards, bacha, all are colorless solids at room temperature. Okay? Very important point once again. Okay? Next is solubility. What do you think about the solubility of alkanes? Will they be soluble in polar solvents or in non-polar solvents? So, bacha, alkane has only carbon and hydrogens attached to it, right? So, alkane has 0 polar bonds. So, alkane in itself, alkane bacha is a non-polar molecule. Correct? There is no polarity in it. है ना? No polarity means nobody is pulling electrons more towards itself. The carbons and hydrogens, bacha, have similar kind of electronegativity, right? They do not create a polar bond. So because it is non-polar, they will be soluble in non-polar solvents. Okay? For example, in benzene, in ether, in chloroform, which means what? Whatever organic solvents are there, right? Organic means which again has a carbon and hydrogen bonds in it. In those solvents, it will be soluble, and also in other non-polar solvents which has 0 polarity in it. Okay? Okay? But they are insoluble in water, obviously, because only, remember one line, bacha, like dissolves, like. What does it mean? That polar will be soluble in polar solvents and non-polar molecule will be soluble in non-polar molecule, which is a very, very important line. Like dissolves like. Okay? And the solubility decreases with increase in their molecular weight. As the weight will begin to increase, the solubility will decrease. Okay? Remember this thing. Next is boiling point. Very important questions are asked from boiling point every time. So, bacha, what happens to the boiling point? So, if the mass will increase, obviously the boiling point will increase. Boiling point is directly proportional to the molecular weight. Number one thing. Okay? And bacha, boiling point is inversely proportional to the branching. Which means what? As the branching increases, boiling point will decrease. Why does that happen? Why does that happen? Because, bacha, for example, look at this molecule. See, I am drawing a pentane molecule over here. Okay? Now, I am drawing its isomer. Isomer means what? I am doing the branching of this pentane molecule. So, the highest isomer that is possible is called a neopentane, right? So, can you see when I have drawn the isomer of this normal pentane to neopentane molecule, can you see that this has developed a kind of circular structure? So whenever I do branching, whenever I am forming a branch out of this, a circular structure is forming, and those circular structures actually have very low, what do they have? They have very low surface area. Because of very low surface area, their boiling point decreases. So boiling point decreases with branching but increases with molecular weight. Is this point clear? We will do certain examples with which it will be even more clear. Now, who can answer this? Isomerism in saturated hydrocarbons is due to. Who can answer this question for me? Isomerism. I just told you what was isomerism. I took a pentane molecule just like this and I created an isomer by making branches out of it, right? I made an isomer of normal pentane. What was I doing? Isomerism in saturated hydrocarbon is due to. It's due to, who can answer this question? I'm looking at the chat box once again. Very, very good question. Jeevan has answered C. And what is PK Prajapati writing? Jeevan has answered C, formation of. Very good. I'm basically talking about formation of branches. Correct, Jeevan. Shiva has answered. Omesh has answered. Ashwis has answered. Very good. Very good. Deepika has answered. Yes, yes. ठीक है. Answer is C, as you can see. You know what is isomerism now. ठीक है. Next question on your screen. Which of the following has highest octane number? Why have I included it here? Because this is given as a fact in your NCERT, right? And all the facts are important because we have already seen how is the January 2024 paper. Facts are very important. That's why I've included this here. Which of the following has the highest octane number? This is a fact from your NCERT. Octane number, bacha, it is something. Okay, I'll tell you what is octane number. Whenever you want a good fuel, है ना? A good fuel for cooking or for driving, right? For your vehicles or for your cooking, a good fuel is something which has a higher octane number. So that octane number. Third week mock test, bacha, where mock test will be happening. See, on YouTube, we'll be conducting another set of mock tests. But if you want to be part of the crash course, which is specifically very, very dedicated for the JEE exam, it will not be of just 1 hour. You can take the entire day for it. So that crash course we're offering, the link is in the description box below. Otherwise, on YouTube, we'll definitely do that. Surah has answered D. Yes, the answer is D, bacha. Which of the following has the highest octane number? It is 2,2,4 trimethyl pentane. Yes, yes, yes. ठीक है? 2,2,4 dimethyl pentane has the highest octane number. Next, we are back to the decreasing order of boiling points. Who can answer this question? The decreasing order of boiling points. The decreasing order of boiling points. Please answer this question for me. The decreasing order of boiling points. Beta, one of the test series will be on YouTube, but it will be a very short test series. If you want to be part of the longer test series, please join the crash course which we are offering, which will have approximately 23 to 24 mock tests and plus 15 test series. Okay? Answer I am getting is A. A, once again, N-pentane, isopentane and neopentane. Very, very good. Jeevan has answered wrong. Once again, Bharat, Shiva, Tashnika, Roshan, Bharat, Sandhani, very, very good. Correct answer is, bacha, this. Okay? As the branching is increasing, boiling point decreases. Very good. The correct answer is A. Very, very good. Okay? Next is, now we are back to the chemical properties of alkane. We have studied about the preparations. Now we're studying about the reactions of alkane. Number first reaction is halogenation reaction. How does halogenation happen? For example, I took a alkane molecule. Okay? And in this alkane molecule, in the presence of Cl2 or light, okay? If you try to, for example, you took a alkane. This is an alkane and you try to react it with simple chlorine. What will happen? In the dark. And if you try to react it in dark, there will be no reaction happening. Remember this thing. If you take an alkane, because I told you alkane is a non-reactive inert molecule, so in dark there will be no reaction, right? But as soon as you take an alkane and you try to react it with chlorine in the presence of light or heat, then what will happen, bacha? You will get an alkyl halide as a product. Remember this thing. Only and only presence of light or heat, you will get an alkyl halide as a product. Very important reaction, very good reaction. This reaction goes through via free radical mechanism. Remember this thing. Free radical mechanism. Okay? This reaction happens through free radical mechanism. This is the best example of that. Okay? In the free radical mechanism, there are 3 steps. This is very important because free radical is the favorite question for any examiner. 3 steps are there. Initiation step, propagation step and termination step. What happens in the initiation step, bacha? First of all, free radical is created by light. You took a halogen. The halogen splits into a free radical, okay, in presence of light. Then that free radical attacks your alkane. In the propagation step, the free radical created now attacks the alkane and then the alkyl free radical is generated and this HX is now left behind. ठीक है. This radical attacks the alkane and the free radical is formed and this both combine to form the HX. ठीक है. Now again this free radical attacks again the halogen atom and it again forms the this free radical. Now this free radical will again attack the alkane molecule and this reaction will keep on going. This is called the propagation step. So after this reaction again this upper wala reaction will happen, then again this reaction, then again this reaction. Okay. Now ma'am, how will this chain terminate if this will keep on going, if they will keep on making free radicals of each other? Then comes the termination step. What happens when one alkyl free radical combines with the another alkyl free radical? A alkane molecule is formed. ठीक है. When one halide free radical combines with another halide free radical, a halogen atom is formed. ठीक है. Now when R dot and X dot combine, then what happens? Your alkyl halide forms. So can you see, even in this reaction, a mixture of products is formed, right? See, simple halogen, simple alkyl halide is not formed. Instead, a mixture of products is formed. Isobutane and N-propane, which will have the maximum boiling point. But isobutane, because butane has a more mass, right? Because butane has 4 carbons more mass, so it will have a higher boiling point. ठीक है? ठीक है? Everybody understood this? So this is how alkyl halide will be formed. ठीक है? Now next is again in the halogenation reactions. I told you that it happens through free radical mechanism. ठीक है? In that free radical mechanism, I told you what happens. Now what is the order of reactivity? Again, the order of reactivity is tertiary free radical is more reactive than secondary free radical than your primary free radical. ठीक है? So the ease of substitution will follow the similar order that tertiary is more than secondary is more than primary. And what will be the reactivity order of the halogens, ma'am? It will follow fluorine is the most reactive, then chlorine, then bromine, then iodine. What do you mean by that? That if you try to react, see, I took another, for example, I took a methane molecule and I tried to react it with fluorine. With fluorine, bacha, the reaction is so violent ki we never do it because it is so violent. It is so reactive and the reaction is explosive in nature. So with fluorine, you will never perform this reaction in reality because it is very explosive. Now with chlorine, we do this reaction. Okay? With chlorine, I told you mixture of products will be formed, which will be one of the product with this CH4 will react with itself and it will form a ethane product. Okay, this will be the first product. The second product will be CH3Cl product. Okay, the third product will be a Cl2 product. So a mixture of products is formed when CH4 reacts with Cl2 compounds. Okay, and the reactivity order followed is this. Okay, and bacha with fluorine again another thing happens. For example, you took a alkane ethane molecule or a propane molecule, and if you're trying to react it with fluorine, what will happen? Fluorine will also break the CC bond. It is so reactive that it has the capacity to break the CC bond as well as the CH bond. So both of these bonds will be broken by fluorine. See, fluorination of alkane is so violent that the cleavage of CC as well as CCH bonds happen with it. ठीक है? ठीक है? Everybody understood this? Now let us see what products are made when I take propane as a molecule. I took propane and I'm trying to react with chlorine and H nu. Okay? What will happen? I took propane. Okay? Now can you see that here how many kinds of hydrogens are present? So can you see that this is a primary carbon, this is a secondary carbon, and this is again a primary carbon. Everybody agrees to this? So therefore it means that this molecule has 2 different kind of hydrogens, ma'am. One is the primary hydrogen and the second is the secondary hydrogen, right? So when you try to react Cl2 in presence of H nu, there are 2 possibilities where this Cl2 can attack. It can attack either on the secondary position or it can attack to the primary position. Everybody agrees to that? It has 2 possibilities of attack, isn't it? Isn't it? 2 possibilities of attack. The next is you again took a Cl2 molecule in presence of H nu. Now what will happen? You took a butane molecule just like this. ठीक है. In butane molecule, how many kinds of hydrogens are present? This is a primary hydrogen. This is again a primary hydrogen. This is a secondary hydrogen. This is again a secondary hydrogen. You try to react Cl2H nu with this. ठीक है. Now there are again two possibilities of attack. The chlorine can either attack the secondary, any of the secondary hydrogens, or the primary hydrogen. So again, two kinds of products are formed. Now the question that arises is, ma'am, which is the major product and which is the minor product? है ना? This is the next question that you should be asking. Ma'am is only F. Ma'am is, what is the question, Umesh? I'm not understanding your question. Please, can you ask? Beta, with fluorine, the reaction is very violent. That's why in your exam, reaction with fluorine will not be asked. So do not worry about it. But just remember that if I try to react fluorine here, if I took fluorine instead here, then this cleavage of bonds also would have happened. Correct? So that's why we don't take fluorine. We start with chlorine or bromine atoms. Okay? Remember this thing. Okay? Now, bacha, the next thing. Secondary halide is stable. Yes. So I'm going to teach you another very important thing in this, which is applicable only to this reaction, only to this free radical reaction. What is that? The reactivity order. I taught you the reactivity order, right? Ki fluorine is more reactive, and then chlorine is more reactive, then bromine, and then iodine. What is meant by that? Then bacha, this, okay, we have another example and then we'll go. For example, in this reaction, what is happening? Here again, this is a primary hydrogen. This is again a primary hydrogen. This is a secondary hydrogen. This is a secondary hydrogen, and this is a secondary hydrogen, right? But now there are three possibilities where this chlorine can attack. Right? It can attack either on any of the one primary hydrogen. It can attack on the secondary hydrogen, which is in the middle, or which is at the end of the here. So these three products are the possibilities with this reaction, right? Right? Now next is ki bacha, reactivity selectivity principle that I was talking about. Which one will be the major product? Which one will be the minor product? So with chlorine, what did I say? Chlorine is more reactive. Did I say that? Chlorine is more reactive. If something is more reactive, for example, I am a child and I am very, very reactive in class, which means I will go and talk to anybody. I will not select my friend group. Whoever is talking to me, I will talk to him first. Whatever is the largest group, I will go there and talk to that group first. So what is meant by more reactive molecule? If chlorine is more reactive, it means what? The major product will be that which is present in abundance. For example, here, let us go back here. Here, can you see that there are three kinds of secondary hydrogens present? Correct? So here, the major product will be these two secondary hydrogens because it is present in the largest quantity. Correct? And similarly, if you go back here, here the primary hydrogens are present in the largest quantity. There are two kinds of primary hydrogens. So because chlorine is more reactive, hence in this case, the primary chlorine will be the major product. Okay? Because there are too many sites for the chlorine to attack. Because it is so reactive, it will attack the most probable site. But if I change the reaction to bromine, if I change the reagent to bromine, what will happen? Only and only the most stable free radical product will be the stable product. For example, in bromine, always the tertiary product will be more stable, then secondary, then primary product. Always remember this. With bromine, because it is less reactive, hence it will take its time to select where I want to attach myself. Chlorine is so much reactive, it is not taking any time to select where I should get attached. So it is getting attached on the positions which is present in abundant quantities. But with bromine, what is happening? It will attack only the selected position. You are tertiary free radical, I will attack to you. You are secondary, I will attack to you. Okay, everybody understood this? Okay. Beta, which question you're asking, Tanishka Pandey? For what question you're asking that? So that was the reactivity selectivity principle that I told you about. The next reaction we're going to study, first reaction of alkane we studied is the free radical reaction, where we are reacting the alkene with a chlorine molecule in presence of light. Okay. Second reaction is combustion. Combustion is very popular reaction you've been studying since the mole concept. You took a alkane molecule and in the presence of oxygen you heat it, right? And what do you get? You get the carbon dioxide and water as product. You should know how to balance this equation, right? Balancing equation you study in mole concept. I'm not going to teach you this. ठीक है? ठीक है? Beta, there is no set safe rule, bacha. Set safe rule is applied whenever we are forming an alkene. है ना? That the rule that you want to use here is the Marconi curve rule. Yes, bacha, you can use the Marconi curve rule. Yes, not the set safe rule. ठीक है? Now here this is the combustion reaction. So many reactions are given here which are not important. You just know what is combustion reaction, and this is one equation. Okay, if you are someone who has hard time to like still now if you can't balance the equation, then this is how you can balance the equation whenever an alkane molecule is given to you. This is the sure shot method of how many oxygens will be used, then how many carbon dioxides will be formed, and how many water molecules will be formed. Okay, so this is the oxidation reaction, the combustion reaction that we were talking about. Okay, now the next is more oxidation reaction. That was pure combustion. In combustion, what is happening? Your alkane is reacting with oxygen and whole of it is getting converted into carbon dioxide and water. But we can also perform controlled combustion, which means what? In controlled combustion, we will get various products. Various products like how? For example, in extensive oxidation, bacha, what happens? What happens? You get a mixture of acids. Okay? You, for example, if I took an alkane, CnH2n plus H2n plus 2. In the presence of controlled combustion, I can either get a ketone or an aldehyde as a product. Okay? This is controlled combustion, controlled oxidation. In extensive oxidation, you will get acids as product. Okay? In less extensive oxidation, you will get a mixture of products which no chain fission has occurred. So this is a theory part. We will let us see what reactions we're talking about. For example, in the catalytic oxidation, now we're talking about controlled oxidation. Okay? Combustion is like oxygen is present in plenty. है ना? When oxygen is so much, then combustion happens. When you want to control the combustion, what do? You take a methane molecule and you take oxygen, and in the presence of catalyst, which is red hot copper or Fe tube, then what do you get? You get methanol as a product. These all reactions are given in your NCERT, hence are important reactions, have been asked in your JEE exams as it is. इसीलिए very important. Next is you again take a methane molecule in the presence of oxygen. Now you have changed the catalyst. Catalyst is molybdenum oxide in the presence of this much temperature. What you get is an aldehyde product. Okay? The next is what happens to the tertiary alkanes. So, bacha, tertiary alkanes, if you try to oxidize it with a strong oxidizing agent like KMNO4, then you will get aldehyde as a, alcohol as a product, which is a tertiary alcohol. You will get tertiary alcohol as a product. So, right now we were discussing about controlled oxidation. Number one, you were forming a primary alcohol, है ना? Number second, you formed a aldehyde. Number third, with number third reagent, you formed a tertiary alcohol. ठीक है? Next is lower alkanes, isomerization reaction of alkanes once again. So remember one thing, that C1 to C3 alkanes are not isomerized. Can you make an isomer of this molecule? Can you make an isomer of propane? There is no possibility of isomer of propane. But ma'am, I can make the isomer of butane. Just like this, I can make isobutane. Right? So, isomerization starts from carbon number 4 for alkanes. Remember this. Butane or higher alkanes, actually when they are heated with aluminium trichloride in the presence of higher temperature, what happens? You started with normal butane molecule. ठीक है. With normal butane, you will get the most isomerized product, that is your isobutane with aluminium trichloride. Very, very important reaction. Okay? And isomerization is also held by heating alkane with all these reagents that is given over here. Okay? But mostly in your exams, AlCl3 will be given and you'll be able to recognize that there's an alkane given and AlCl3. It means isomerization will happen. So all these things you need to understand. Good afternoon, Anutanaki. ठीक है. Molybdenum, yes, yes. ठीक है. Out of the two, what are you asking, ma'am? Reason for what, Tanishka Pandey? Now next is aromatization. We studied about what, bacha? We studied about isomerization. Next is aromatization. So whenever you have number 6 or above, right? 6 or above carbon alkanes, you can even make a aromatic product out of this. The number first aromatic product that you must all be aware of is the benzene product. Benzene is made up of 6 carbon atoms, right? That is why aromatization starts with those alkanes which have 6 or more number of carbons. And with what catalyst it happened? With the oxides of vanadium, molybdenum or chromium supported over alumina. Under these catalysts, bacha, what is happening? It is converting into a benzene ring. For example, you took a normal hexane in the presence of chromium trioxide and alumina. What will happen? You will form a benzene. Now you took a normal heptane in the presence of same catalyst. You will get a toluene product. Can you see? So you took a 7 carbon here, 7 carbon alkane over here. So out of this, 6 carbon got converted into benzene and the 7th carbon got attached as a methyl over here, right? Similarly, you started with 8 carbons over here in normal octane. What will happen? For the 6 carbon, the benzene ring is formed. Okay? For the 6 carbon, the benzene ring is formed. For the 7th carbon, there is a methyl group. For the 8th carbon, again, there can be a methyl group, right? Either in this way the methyl groups can be attached or even the methyl groups can be attached all together and form a ethyl benzene just like this. So you should know all these aromatization reactions as well. Okay? Ma'am, for pentane with chlorine, which compound is forming major product? 2. Okay. So let us take Tanishka's question. Tanishka is asking some question to me. She is asking, ma'am, pentane with chlorine. So I took a pentane molecule. 1, 2, 3, 4, 5 with chlorine. ठीक है. With chlorine, ma'am, major product will be 2 chloropentane or 3 chloropentane. ठीक है. Major product will be, bacha, can you see here the major products can be 2, right? Because can you see the primary carbons are also 2 here. The secondary carbons are also 2 here and the tertiary carbons are here, right? So the major product will be here 2 chloropentane. 2 chloropentane. ठीक है? Why 2 chloropentane? Because secondary free radical will be stable, right? You understand this? The secondary free radical will be stable, so the chlorine can attach over here. ठीक है? And because bacha, chlorine is a more reactive molecule. One which is more reactive is less selective molecule. It will not select. It will not wait for the tertiary free radical to form. It will be, the major product will be the secondary, and also there are 2 secondary sites. Can you see the chlorine can attach over here also, over here also, right? So there are 2 secondary sites and only 1 tertiary site. So because the reactivity of chlorine is so much more, hence it will react the secondary site more than the tertiary site. ठीक है? Oh yes, this is also a secondary carbocation only. You are right about that. This is also a secondary carbocation only. Then again, bacha, what will happen? This carbon is in abundance. Na? This carbon, can you see? This carbon is in abundance. Sorry, this carbon is in abundance. Then also 2 chloropentane will be the most major molecule. Because the chlorine can attack here also, the chlorine can attack here also. है ना? So there are 2 possible sites for the chlorine to attack. So therefore 2 chloropentane, again in this case also it will be the major product. ठीक है? Everybody understood this? Okay, let's move forward. Let's move forward. ठीक है? Next is pyrolysis. Understood, Tanishka? ठीक है, very good. Pyrolysis, we're talking about pyrolysis means what? We took an alkane and in the presence of heat, you are breaking that alkane molecule into smaller molecules. I have a 5-chain alkane. For example, I have a pentane molecule. Now in the presence of heat, I'm breaking that pentane into smaller molecules. I'm breaking the chain. That is called pyrolysis. Another name for it, it is also called cracking. ठीक है? Cracking or pyrolysis are the same thing. So what do? You take a bigger alkane and in the presence of heat, you break it down into smaller alkanes. ठीक है? This is the only thing that happens. And but it happens in the catalysts used are the chromium, vanadium and molybdenum oxide. In the presence of the oxides of chromium, vanadium and molybdenum, once again, this thing happens. ठीक है? Now next. A liquid hydrocarbon can be converted into gaseous hydrocarbon by. The question is on your screen. Who can answer this question for me? Who can answer this question for me? Yes, Bacha. Yes, Mahesh. 3 secondary sites. Sorry about it. That was a silly mistake I did there. Yes, there were just 3 secondary sites. Correct. Now, who can answer this question? A liquid hydrocarbon can be converted into gaseous hydrocarbon by. Beta, Tanishka, such questions won't be asked in your exam, so do not get fussy about it anymore. Okay? So, whatever, see, very basic chemistry will be asked. So, whatever I'm teaching you here, now focus on those examples. I can bet on you that no more examples outside of this will be asked. Who can answer? First answer I got is from Ashik. And second answer from Subhrakanti Biswas and KMC. KMC is answering E. There's no option E, bacha. Shiva has answered C. A. Ashik. Yadu has answered A. Aspirant. ठीक है. Actually, the answer is cracking, bacha. Cracking. I just told you, cracking is another name for pyrolysis, right? I just told you cracking is another name for pyrolysis. What happens in cracking, bacha? I took a liquid hydrocarbon was what? Liquid hydrocarbon was C8 to C13, I guess. Sorry. No. Liquid hydrocarbon was C5 to C17, right? This was the liquid hydrocarbon. Now you are breaking this hydrocarbon into gaseous. Gaseous was C1 to C4. So what you're doing, you took a bigger hydrocarbon and you're breaking it into smaller parts, right? Liquid to gas, how will you do? What is meant by that? That you took a bigger hydrocarbon, which is a liquid hydrocarbon, and you're breaking into gaseous, which is smaller hydrocarbons. How do you do that? Through the process of cracking, which is also known as pyrolysis. ठीक है, I just explained to you this thing. I just explained to you. Yes, cracking, not B. How can you convert a liquid hydrocarbon to gaseous by hydrolysis? What are you saying, bacha? ठीक है, for example, I took a hexane molecule, which is a liquid, and after cracking it, we sort it down to smaller molecules like butane or ethene gas. ठीक है, now you can break it down into anything you want. Okay? It doesn't matter that you will form butane and ethene gas only. You can make any molecule. You can make even a pentane molecule, but pentane is a liquid only, so you cannot make pentane. You can only make a butane, ethane, methane, whatever smaller molecules you want, you can make out of it. Okay? Now, why do the CC bonds rather than CH bonds break during pyrolysis of alkane? Remember another thing. Whenever we're doing pyrolysis, we are breaking the CC bond. है ना? Whenever you're heating the hydrocarbon in presence of catalyst, the CC bond is breaking and the CH bond is not breaking. Why is that the case? Because, bacha, the CH bond, what is happening? The carbon is a small molecule, hydrogen is a small molecule, and because hydrogen is a very, very small molecule, it forms very strong bond with carbon. So, CH bond, bacha, is a very strong bond. Because this bond is so strong, hence it is very hard to break this bond through just heating. That is why only CC bond is broken, because that is a weaker bond. Okay? That is why this thing happens. The reason is written over here for your PDFs. Now we are moving to alkenes. We have completed alkanes, correct? Now alkenes, what you should know about alkenes? We're starting another point, another very important topic, which is alkenes, right? Alkenes are unsaturated hydrocarbons having carbon-carbon double bonds. Remember this thing. Okay? This is an alkene with a double bond in that. Okay? And their general formula is CnH2n. Correct? Everybody knows this. You should know this general formula. The other thing is, in this structure of alkene, what you should know, the carbon is sp2 hybridized. Every double bonded carbon is sp2 hybridized. What is the bond angle? The bond angle is 121.4 degree, around 120 degree, because it is a planar structure, right? What is the bond length? Bond length, the double bond length, bacha, here is 134 picometer. Can you see? It is smaller than the alkane bond length. The C single bond C bond length was 154 picometer. This is 134 picometer. Hence, it is smaller. And we know that smaller bonds are stronger bonds. So, this is a stronger bond. Even though, and remember one more thing, even though this is a stronger bond, alkenes are more reactive than alkanes. Hai na? What am I saying? This is a stronger bond, but still alkenes are more reactive than alkanes. In alkanes, I told you they are unreactive inert molecules. Why is it more reactive, bacha? It is more reactive due to the presence of pi electrons. Can everybody see? Multiple bond is what? They have pi electrons above and below the plane. Due to the presence of these pi electrons, they become reactive. They show reactions. These pi electrons show reaction, hence they are reactive molecules. Next, let's talk about the physical properties. So, bacha, the alkenes, number one molecule of alkenes start with 2 carbon atoms, right? Always remember, alkenes first member start with ethene, because there cannot be a carbon atom and a double bond over there. Hai na? To form a double bond, I need 2 carbon atoms. Hence, the first member of alkene is a 2 carbon atom chain, which is a ethene, right? So, C2 to C4 are again gases, C5 to C15 are liquids, and C16 above are solid like wax. Okay? Now, let's talk about their color. They're colorless and odorless. And again, because these are non-polar molecules, hence they are insoluble in water but soluble in organic solvents. Correct? Because they are non-polar, so they will be soluble in another non-polar substances, which are your organic solvents. Let us talk about their boiling points and melting points. They will again follow the same order, bacha. They are directly proportional to the molecular weight. As the molecular weight will increase, so will the boiling point and melting point. Okay? And boiling point and melting point decreases with increase in branching, which I just discussed. As the branching will increase, the molecule will become more round. Hence, it will have lesser surface area. Hence, the boiling point will decrease. As the branching increases, boiling point decreases. Correct? Everybody? Now, next is physical properties of alkene. We are talking about physical properties. I've already discussed all. Acha, theek hai. One more thing is the melting points of cis isomers. So, I'm drawing alkene over here. One alkene I'm drawing here. C double bond C. Here is the CH3. Here is the CH3. Here is the H. And here is the H. This is the one alkene I have drawn. Okay, let me change it. I'm adding, instead of CH3 here, I am instead adding Cl molecules. Okay, this is one alkene. The other alkene is this, C double bond C. Here it is Cl, here it is Cl, here it is H, and here it is H. Can everybody see these two kinds of alkenes? Hana? This is a cis alkene and this is a trans alkene. Everybody can see that? This is a cis alkene, this is a trans alkene. Right? Now what is... Beta, not right now. I cannot give you a break right now. Abhi hai, somebody is asking for a break already. Ha! Now this is a cis alkene and this is a trans alkene. Now let us talk about their melting point. I always tell people that bacha, the melting point only and only depends upon the crystal structure, right? Now, if the crystal structure is very symmetric crystal structure, then the melting point will increase. Okay, remember this thing. So, can you see that the trans isomer actually forms a very symmetrical crystal structure? Okay, so the melting point of cis isomers are lower than the trans for the same reason. I'm talking about melting point. Melting point depends upon the crystal structure, and trans isomers actually form very symmetrical crystals, bulky cis isomers are not able to do that. Hence the trans isomers, hence the cis trans isomers will have a higher melting point. Correct? Now let's talk about boiling point. In boiling point, the case reverses. In boiling point, what matters is their molecular weight. Yes, that matters. And the next thing that matters is also their polarity. More polar will be the molecule, more will be the boiling point. Remember this. Okay? Now let's look at their polarity. Here chlorine is a more electronegative molecule, hence it will pull electron towards itself. This chlorine will also pull electron towards itself, right? So what is happening? Both are pulling electrons towards itself, hence the addition vector is upwards. Hai na? And in this, what is happening? The vector product, the dipole moment is positive in the upward direction. So can you see that this cis isomer has a positive dipole moment which is more than 0. Correct? But look at this trans isomer. What is happening? This chlorine, because it is more electronegative, will pull the electron towards itself. This chlorine, again more electronegative, will pull the electron towards itself. Now can you see that both of them are pulling electron towards itself? Hence, one is pulling on the upward direction, one in the below direction. Hence, it cancels out, right? So here in trans, the dipole moment is 0. Correct? Now, can you see that the dipole moment exists for the cis isomer, but the trans has 0 dipole moment. Hence, the boiling point order is cis boiling point is more than trans, right? And the melting point is trans melting point is more than cis. So, this thing you need to remember. I've also told you the reasoning, because in assertion reason, this reasoning can be asked and has been asked in exams. Okay, everybody? Everybody understood this? Everybody understood this? But it depends on what is your strength. I can even take a 8-hour session, 10-hour long session, but right now I'm not going to do that. I'm going to finish in like another 1 to 2 hours. Okay? Next is, we've already reached alkene, bacha, only alkyne, and one more thing is left, which is your aromatic compounds. So we are going to complete it another 1 to 1.5 hours. Okay? Now we have reached preparation of alkene. Everybody understood that? Beta, not in every, Mahesh is asking, ma'am, is boiling point and melting point inversely? Not in all the cases, correct? Right now we're talking about alkenes. Hai na? In alkenes, the boiling point and melting point depends on all these parameters. That's what I'm teaching you. You have to learn about the parameters here. Keep boiling point depends upon the dipole moment as well, while the melting point depends upon the crystal structure. That is it. Due to that, they are not inversely proportional every time. They happen to be inversely proportional in this case. Not every time this is true. Okay? Now preparation of alkenes we're doing how to prepare the alkenes. Number first, we're going to prepare them from alkynes once again. Alkynes, what can you do? They have a triple bond here and 2 hydrogens, right? And you want to convert this triple bond into a double bond. What do you want to do? You want to add hydrogens. So you do hydrogenation reaction. Again, this is a kind of hydrogenation reaction, isn't it? Because you are adding hydrogen. And also you are adding, you are not eliminating anything, you are not substituting anything. This compound remains as it is. You're just adding 2 more products. So this can also be called as a addition reaction, isn't it? So many names can be given to this reaction. This is the addition reaction. This is the hydrogenation reaction. What happens? You took an alkane, and in the presence of hydrogen and in the presence of Lindlar's catalyst. What is Lindlar's catalyst? It is palladium and BaSO4. You actually get a alkene product. What are you getting? two hydrogens get added over here and you get a alkene product. The reaction stops at alkene and alkanes are not formed. Why? Because your BaSO4 here acts as a poisonous catalyst. It means what? That it stops the reaction at alkene and it doesn't move forward and form an alkane molecule. है ना? Because from alkene you can again form alkane, but because of BaSO4 or another thing you can use is CaCO3. So you can use either of these things and both of them are poisonous catalysts and they stop the reaction at alkene. This is the first preparatory method for alkene. Correct? Yes, bacha, it is wrong. This hydrogen will not come here. This will come here. Okay, this will come here. There are many printing mistakes, I can see that. But you get the idea, right? So the two hydrogens will attach over here. The hydrogen will not be here. Okay? Next reaction is from alkynes once again. From alkynes, bacha, here can you see that this is again a cis addition. This, I told you, the addition of hydrogen in presence of BaSO4 in palladium BaSO4 is a cis addition, means both the hydrogens will attach from the same side, either from below or from the above. Correct? It is a cis addition and cis product will be formed. Can you see a cis alkene is formed? Cis alkene is formed with this reaction. These are very important things not given in NCERT but are asked in your exam. Okay? Next is from alkynes. What are you forming? From alkynes can be reduced to trans alkene by using. Now you formed a cis alkene. Now how to form the trans alkene? You again took a alkyne molecule and in presence of sodium and liquid ammonia. Remember these names, sodium and liquid ammonia. What are you doing? You are again adding hydrogens, but they add on the trans position. So you get a trans alkene with sodium and liquid ammonia. With hydrogen, palladium BaSO4, you're getting a cis alkene. Here you are getting a trans alkene with sodium and liquid ammonia. This was the question in your JEE 2024. This question, exact question came in your JEE 2024, when the trans alkene will be prepared and when it will not be prepared. See this here, I told you, see, in the given reactions, identify A and B. This is JEE Main 2024 question added over here. Who can answer this? Who can answer this? Yes, Jeevan, yes, Jeevan. Answer this question for me. The A, you have to identify the A reactant and the B product. And the B product. What will be the reactant? What will be the product? Again, this was a JEE Main 2024 question. I'm looking at the chat box. First answer I got, but Tanishka Pandit D. Jeevan has answered B. Jeevan has deleted the answer. Yes, Jeevan again D. D. Very good, very good. Ashik has answered C. Jana has answered D. Okay. Ashik C. Okay, you're repeating the answers. And Shiva has answered D once again. So the correct answer is D. Correct answer is D. Why is D the correct answer? Why is D the correct answer? Here, what should I take? What should I take? I get the alkene product. So this should be the reactant. C, triple bond. Here should be the C and here should be the C2H5 product. So what is this name of this thing? The name of this thing is 1, 2, 3, 4, 5. 5 and on the second number there is a pentyne group, so this name is 2-pentyne. Okay? And whenever you add liquid ammonia, then a trans product is formed, a trans alkene will be formed, hence trans 2-butene will be formed, hence answer is B. D, sorry. Correct? Correct. Next, another very, very beautiful question. I love this question. Again, you have a cyclooctatriene product. Nee, cyclooctaene product. Can everybody see? Cyclooctaene product, and in the presence of H2 and Linder's catalyst, you have to tell me the product. And in the presence of sodium and liquid ammonia, you have to tell me the product. Why have I attached this slide, bacha? Because I will show you the beauty of stereochemistry. Right now, you didn't understand the beauty. Okay? right now everybody knows ki if this is the product with H2 and Lindlar's catalyst, ma'am, one or both of the H, what will happen? Sorry, 1 second. Both of the H, ma'am, will add on the same position, right? This is your answer with the Lindlar's catalyst, right? But what will happen with sodium and liquid ammonia? How will you attack the hydrogen? Now let us see this beautiful example. Can you see? Now with H2 and Lindlar's catalyst, what is happening? Both the hydrogens got attached on the similar side of the double bond, correct? But with the liquid, Na and liquid ammonia. This is Na and liquid ammonia. What is happening? Can you see the hydrogens are added at the trans position, and due to that the shape of this molecule got crooked. Can you see the shape of this molecule just to make a trans product? Can you see that to this double bond, I've already added hydrogen in the trans position. Now I also want to add the alkyls to the trans position. So if this is the one position of alkyne, this should be the other position, right? So this is how the product is formed. Can you see a trans product beauty is seen like this? Okay, everybody understood this? Everybody understood this? Okay. Next is the reduction of 4-octane with hydrogen in the presence of palladium and CaCO3 and quinoline gives. Who can answer this question? Who can answer this question for me? The reduction of 4-octane with hydrogen in the presence of palladium and calcium carbonate. Again, this is used as a poisonous catalyst and quinoline gives. I took 4-octane as a product, as a reactant. What product will I get? With palladium CaCO3. One answer I got by Jeevan, B answer. Jeevan has given me cis 4-octene. Okay. Tanishka Pandey has also given me B answer. Very good, Tanishka Pandey, aspirant. Shiva Ashik has also given me the B answer. Why are rest of the students not answering? Why are the rest of... Aswik has also given me A. Aswik has given me the wrong answer here. The answer is cis, bacha. In the presence of palladium, what happens? Cis addition happens. Correct. The answer will be cis 4-octene. Correct. Now next is from monohalides. Next we are preparing from monohalides we are doing the reactions. Okay. So I just took a monohalide means what? On one carbon there is just one halogen atom attached. Monohalide means what? In the entire compound there is just one halogen atom attached, and in the presence of alcoholic KOH I'm trying to make a alkene product. So always remember this reagent, or take out your notebooks and write down this reagent, alcoholic, because instead of alcoholic, if aqueous KOH is given to you, then the answer would be different. With alcoholic KOH and one halogen atoms, what you get? You get a alkene product. Remember this thing. What is happening? This halogen goes away from here and the hydrogen goes away from here, right? So what is happening? This is an anti-elimination reaction. If the halogen goes away from the bottom, the hydrogen will go away from the top. So this is an anti. What is happening? This is the anti-elimination is happening over here. Yes, this is a beta elimination also. Why? Because to the carbon to which the halogen is attached is called the alpha carbon, right? And the carbon right next to it is called the beta carbon. Always remember this. So this is the beta elimination. From the beta the hydrogen is going, and from the alpha this is going. So this is also called the beta elimination reaction. Somewhere it's written. Okay? And then in the presence of alcoholic KOH, this elimination reaction happens and you get a alkene over here. Okay? If instead of alcoholic KOH, even sometimes a strong base, heavy base, for example, this kind of base, C2H5OK minus can be used. This kind of base, which is what? This kind of heavy base can be used, and this also creates a alkene. See, again, what I am doing, I took a monohalide and the halogen goes away from here, the hydrogen goes away from here in the presence of C2H5O minus, which is also a very, very strong base, very, very good base, correct? And an alkene product is formed. What kind of alkene product is formed? ठीक है, everybody understood this? See, this is also called beta elimination if you look into the reaction mechanisms over here. ठीक है, and what are the reagent used? The reagent are hot alcoholic solution of KOH is used. ठीक है, or even NaNH2 can be used, or tertiary butoxide in potassium can be used. Can you see all the heavy bases? Tertiary butoxide, ethanol, ethanoxide is used, or your alcoholic KOH, or your NaNH2. All these are very, very strong bases. All these reagents are, bacha, remember this thing, these are very, very strong bases. And what do strong bases do? They make alkenes out of this product. See, the beta elimination reaction is shown over here to you too. ठीक है? This is how the reaction mechanism. Why alcoholic? Bacha, because it acts as a very strong base. Aqueous, if you take an aqueous, ठीक है, I'm again writing over here. See, example, for example, I took the same CH, CH, CH. Here I'm also taking H, here I'm taking X, here I'm taking X. Now I try to react it with aqueous KOH instead. ठीक है, instead of alcoholic, I took aqueous. What will aqueous do? It means it is in water. है ना? It means the KOH is in water. It means it will give away me K plus ion and OH negative ion. Isn't it? Isn't it? This ions it will give to me. Now in aqueous KOH, instead of elimination reaction, what happens? Substitution reaction happens. So what will happen? This will just substitute the good leaving group, which is the halide, and instead of this you will actually get a CH3 CH2OH product. So we started with a halide product and in the end you got a alcohol product. This is with the aqueous KOH. So aqueous KOH actually gives you the substituted product. Remember this thing. While the alcoholic product gives you the alkene. Here you are substituting the halogen with the OH atom over there. है ना? But in the alcoholic KOH, you're getting the alkene. This thing is clear to everybody? This thing is clear to everybody? Yes, that is nucleophilic substitution reaction, Asvik. You are right about that. ठीक है, correct. इसीलिए alcoholic. Please look at the reagents. What is given over there? Sodium and liquid ammonia. Look at the reagent. See the reagent. Write down the reagents in a copy. I'm going to tell you another version of liquid ammonia and then you'll get confused. Then you will get confused what is happening. Okay, now let's look at the dehydrohalogenation of alkyl halides, regioselectivity. For example, this is the alkyl halide, this is the bromine molecule right here. Okay, and now it is asking to you which one will be the major product, which one will be the minor product. Okay, so this is, can you understand, this is the alpha carbon here. The carbon to which the halogen atom is attached is called the alpha carbon. Now this has two beta carbons. One beta carbon is this and the other beta carbon can be any two of these. These are the same. Okay? So we have two kinds of beta carbons attached. Now from where the hydrogen will be lost? That is the question. From where? So if you lose hydrogen from one of these carbons, then this kind of product will be formed. Correct? This kind of elimination product, alkane, will be formed. But if you lose hydrogen from somewhere over here you lost, then an alkene will be formed over here. Okay? So can you see that this alkene is a more substituted alkene, right? So here what happens, a more substituted alkene will be the major product, which is also called the following the Z-Sev rule. This is also called that it follows the Z-Sev rule. ठीक है, everybody is understanding this? ठीक है? हाँ जी, हाँ जी. Everybody is on. This will be the major product. The more substituted alkene will be the major product, and the least substituted will not be, because the hydrogen is lost from the beta position. Correct? Now from the dihalides you're trying to form. From the dihalides, that was the monohalide. From the monohalide, we were forming the alkene using all those bases, like strong bases like alcoholic KOH or tertiary butoxide or ethanoxide or any NH2. All those strong bases we were using to form an alkene out of monohalides. Now let's talk about dihalides. Two halogens are present in the same carbon chain. Now what happens? There are two kinds of halides, right? Dihalides. One is the gem dihalide. Gem means when both the halogens are attached on the same carbon. This is the carbon, and on the same carbon two halogens are attached. It is called the gem dihalide. Now how to form alkene from gem dihalide? You take zinc. What are you taking? You're taking zinc and you're trying to react it with this, and what will be the... Okay, see what has happened over here. I prepared these slides in Google Slides, and what happens here? Oh my god, I don't even know. Okay, so what happens here, bacha? Again, this kind of alkene is formed. CH R CH double bond CH R. This kind of alkene product is formed. Please forget this product. Do not look at here. And also do not look at this product as well. These are wrong. Okay? Okay? Because sometimes what happens when I open my Google Slides in the PowerPoint, everything shifts to somewhere, I don't know where. Okay? Everybody is understanding? So I took a gem dihalide and in the presence of zinc, I'm heating it. What is the alkene I'm getting? So this was the gem dihalide, right? So it reacts with itself and form a alkene just like this. So again here, symmetrical alkene, even number of alkenes will be formed in this case. Similarly, if you took CH3, CHCl2, what I'm taking CH3, CHCl2. Okay? And I'm trying to react in presence of zinc. Then what will happen in presence of zinc? This will react with another CH3, CHCl2. This Cl2 will go away and they will form a double bond with each other. Hence, the final product will be CH3, CH, double bond CH, and here it will be CH3. So this is what kind of symmetrical alkene will be formed with the gem dihalides. Everybody is following this? Everybody is following this? Okay? Next, from vicinal dihalides. Vicinal means what? That the two halogens are present on separate carbon atoms. On separate carbon atoms it is present. For example, one halogen is here, the second halogen is here. Okay? So they are side by side but on separate carbon atoms. Now how will you form alkene from vicinal dihalides? You again use zinc dust and heat it. Same reaction. But what will happen? Both of these halogens will go away and instead a double bond will be formed. I will try to write in a fresh page. Do not look at here. See, I took R, C, Cl over here, C, Cl over here, and here again R was there. I will attach hydrogen and hydrogen. Okay, this is vicinal dihalide. What is this? This is vicinal dihalide. From vicinal dihalide, I again gave it zinc dust. In the presence of zinc dust, what will happen? This Cl2 molecule will go away and instead RCH double bond CH R will be formed. What will happen? As the Cl2 goes away, a double bond gets formed over here. So this is the product that is formed. Okay, this is the product that is formed. Yes. Okay, everybody understood? Next is, if the two dihalides, can you see? If the vicinal dihalides are not right next to each other, but like see this halogen is here, then leaving one carbon, skipping one carbon, the another halogen is over here. Now in presence of zinc dust, bacha, what will happen? No alkene will be formed. Instead, a cycloalkane will be formed just like this. And I will tell you one more interesting fact, which is कि बच्चा cycloalkane and your alkene. Cycloalkane and alkene both have same general formula, which is CnH2n. Correct? Cycloalkanes and your alkenes have same general formula CnH2n. You can check it via this. For example, here 3 carbons are present, right? So how many hydrogens should be there according to this formula? 6 hydrogens. Count the number of hydrogens present over here. CH2, CH2, CH2. 6 hydrogens are there. Hence, this compound also have the general formula of C3H6. Hence, the general formula of cycloalkane and alkenes are same, which is CnH2n. So if the halogen atoms are present skipping one carbon, then your cycloalkanes will be formed, its cyclic compound will be formed, and these halogens will be eliminated. Okay? This is clear to everybody. Now let's do some questions. Let's do some questions. Reaction of trans 2-phenyl 1-bromocyclopentane on reaction with alcoholic KOH. Now I know alcoholic KOH means what? I have to make a alkene out of it. I understood that thing. Now reaction of trans 2-phenyl 1-bromocyclopentane on reaction with alcoholic KOH gives what? You will not be able to tell the product until you pick up a pen, draw the structure in your notebook and tell me the answer. What do you think should be the answer to this? What do you think should be the answer to this? First, draw the molecule. The chain. What is the chain? The chain is, the longest chain is a pentane molecule, also a cyclopentane. So I'm going to make a cyclopentane over here. This is how a cyclopentane looks like, correct? And at the second position, there is a phenyl, and on the first position, there is a bromo. So phenyl means a C6H5 ring is over here. It means a hydrogen will be here. This is the second position. On the first position, there is a bromine attached, and that too at the trans position. So trans means if the phenyl ring is here, the bromine should be here, isn't it? Isn't it? And the H should be here. So this is the how I can make the trans position. Trans 2-phenyl 1-bromocyclopentane on reaction with alcoholic KOH produces what? What should be the answer to this? Who can answer me this question? I'm looking at, okay, somebody has answered me D. 3-phenyl cyclopentane. 3-phenyl cyclopentane. No, this doesn't seem to be the right answer. D. Jeevan has answered. Abracadabra has answered. Mim Prajan has answered me C. And Mahesh has answered C. Sandhani has answered. Please look at what can be the answer to this question. C, I'm getting so many answered. Very, very good. C is the correct answer, 1-phenyl cyclopentane. Why is that the answer? You will ask me once again. C, 1-phenyl cyclopentane. 1-phenyl cyclopentane. Okay, everybody understood? C, correct. Okay, everybody understood. So this is how the reaction will take place, and here the alkene product will be formed. Okay. Next is dehydration of alcohols we're talking about. Now next is how to form alkenes from alcohols. So alcohols means what? I have an alcohol over here. So I will do what? I will do dehydration of it. So if I have an alcohol here and I will have a hydrogen somewhere, right? So what is eliminating out of this? H2O product I'm eliminating if I'm making from alcohol an alkene. This is what I'm eliminating, H2O molecule. Hence it is called the dehydration of alcohol mechanism. So I took an alcohol in presence of some acid. What will happen? Some acid, and alkene will be formed. That is it. That is all you want to know. Okay, any acid. Can you see? They have taken H2SO4, H3PO4, P2O5 or Al2O3 in presence of all these acids. What is happening? An alkene product is forming. Okay. Next is again dehydration of alcohol. Let us look at the example. I took a ethanol. What did I take? I took an ethanol, and in the presence of acid, what will happen? A simple alkene will be formed. Correct? See, do not look at whatever is written over here. When I took, okay, just remove this. When I took a ethanol, simple CH2 double bond CH2 alkene will be formed. Similarly, you took a cyclohexane and here the OH is present. Again, what will happen? Again, bacha, the alkene will be formed. The hydrogen will be lost from here. Okay, OH goes from here, hydrogen goes from here, the alkene will be formed. Similarly, you took a tertiary alcohol over here. In tertiary alcohol, again what will happen? The OH will go from here and the H will go from here, and a tertiary alkene just like this will be formed. Okay? In presence of acids, what is happening? An alkene is getting formed. And bacha, this reaction, I just discussed this, right? This reaction happens through carbocation mechanism. Can everybody see the carbocation? We started with what? We started with this. We started with here. Let us look at this. Look at this alcohol. Can you see a secondary alcohol over there? And to this secondary alcohol, the H plus attacks. So to this OH, the H plus will attack and it will become a OH2 plus ion over here. This hydronium ion is easier to leave. This is a good leaving group. This will leave, leaving the carbocation over here. This will become a carbocation, isn't it? If this will become the carbocation, now it has two possibilities to either take the hydrogen from here or the hydrogen from here. So two kinds of alkenes can be formed once again. One can be the primary alkene, the other can be the secondary alkene. This is the secondary alkene and this is the minor product. This is the major product. Again, the major product is selected by the ZSEF rule. Okay? The ZSEF rule. Do you want me to make you understand this once again? Because I think I've explained it to you already, how the carbocation mechanism happens. If you are not understanding, please ask me. I will make you understand it once again. Once again. If you are not understanding, hello Varun, hello Varun. If you want me to explain this carbocation mechanism once again, because we already talked about it, otherwise I will not explain it to you. Should I move forward? Please let me know. Should I move forward? Should I move forward? Chalo. Next is, beta, again I told you that this happens through the carbocation mechanism, right? What? Dehydration of alcohols happen to carbocation, hence rearrangement is possible. What is possible? Rearrangement. Remember this thing. Anything that takes place through the carbocation mechanism, rearrangements are possible in them. For example, you took a alcohol just like this. You took a alcohol just like this, which is a secondary alcohol in presence of acid. What will happen? What will happen? Number first, here is the H plus ion this acid will give. This is the H2SO4. It will give away the H plus ion. Now this oxygen electron pair will attack this H plus. This will attack. Now what will form, bacha? This will form CH3, C, CH3, CH3 and C. And here OH2 plus will be formed, right? And here the CH3 is there. Okay? This is how the product will be formed. This OH2 plus is a very good leaving group. So it will leave. Leaving behind what? Leaving behind your CH3, C, CH3, C, CH3. Here is the CH group with a positive charge, correct? And here is again your CH3 group. This is a secondary carbocation. But can you see right now that it has the possibility of converting into a tertiary carbocation because the carbon is right next to it. So what will happen? A 1,2 methyl shift will happen. What will happen? 1,2 methyl shift. 1,2 methyl shift will happen. What does it mean? That this methyl group will shift to this position and the carbocation comes over here. So after the 1,2 methyl shift, this will be the product. CH3, C, CH3, one methyl has shifted over here, which is again CH3. Here it will be CH3 once again. Here the CH was there and the positive charge comes over here. Now can you see that we have made a tertiary carbocation which is so much more stable. So now what will happen after making the tertiary carbocation? The hydrogen will get lost from here, right? Because it's a more substituted alkene will be formed in this manner. So the hydrogen can be lost from two places. Now this carbocation has the possibility of taking hydrogen either from this place or from this place, right? So two kinds of possibilities are there. So the major product will be formed will be this CH3C, CH3, double bond C, and here it is again CH3, here it is again CH3. So this is the major product because it is the most substituted alkene is formed in this case. Okay? Otherwise, the double bond can also come over here, but that will be the minor product. So let's not talk about it. Everybody understood this? Okay? See, look at here. The major product is formed in this case, just like this. Now, let's talk about the next hydrogenation reaction. The main reaction of alkenes are electrophilic addition reaction. Remember this thing. What kind of reactions alkenes show? Number one question, they show electrophilic addition reactions, ma'am. What is electrophilic, madam? Electrophilic means what? The alkene molecule has a double bond in it. The double bond has what? The double bond is called pi electrons, right? The double bond is made up of pi electrons. Therefore, this double bond is electron rich bond. Remember this. This double bond is electron rich bond. Okay? Ma'am, please write ME for saving time. Yeah, thank you, Anas. Thank you so much. Okay? Now, this is bacha, the electron rich bond that I'm talking about here. Okay? Now, because this is electron rich, what will I attract? If I'm electron rich, what kind of reactions can I show? I can show electrophilic. Electrophilic means what? Whatever are electron loving species will show reactions with me, because I'm electron rich, hence I will show electrophilic addition reaction, which means what? Electrophiles, which are positively charged molecules or which have a deficient of electrons, will actually react with the alkenes, right? Now, number first reaction that we're talking about is again hydrogenation of alkenes. Hydrogenation is once again the same thing, that both the hydrogens attack from the same position in the presence of any catalyst, nickel, platinum, palladium, and your simple alkane is formed. This is also a kind of electrophilic addition because you're adding something, right? So this is an addition reaction. Okay? Next is, who can answer this question? You have been given an alkyne product. Okay? And you are given two different kinds of reagents. Number first is sodium and liquid ammonia reagent. The second is PdCaCO3 reagent in the presence of CH3CO2Pb. The minimum heat of hydrogenation is in. Who can answer this question? The minimum heat of hydrogenation is in. Yes. Who can answer this question for me? The minimum heat of hydrogenation. Yes, bacha, that was the Sidzef product. Minimum heat of hydrogenation means what? Understand the question. Minimum heat of hydrogenation. Who will have the minimum energy? Which will be the most stable, right? That will have the minimum heat of hydrogenation. That product will be the most stable product. Just understand it by these terms. So you have to identify the most stable which one will be the more stable product, whether will it be the A product or the B product. That is the question. The answer I'm getting by Jaya Harish is A, by Ashik is again A. Okay? Okay, Mahesh is C. I'm getting C. Both have equal. No, bacha, both will not have equal product. Why? Because in the first case, trans-alkene is formed. What will happen with the product A? Product A will be a trans-alkene just like this. CH3, C double bond C. Here it is the CH3. Here it will be the H. Here it will be the H. If everybody agrees, this will be the A product. What will be the B product? The B product will be in the presence of palladium and CaCO3. Hydrogenation happens, right? Hydrogenation happens in cis condition. Hence, the cis alkene will be formed CH3, C double bond C, CH3. Here will be the H and here will be the H. Everybody agrees to this? Here the trans alkene is formed. Here the cis alkene is formed. Correct? Now, which alkene is more stable will have the least minimum heat of hydrogenation? Which is the most stable alkene? Now answer to me. The more stable alkene is always bacha the trans alkene. Okay? So the answer is A, which everybody was answering. Very, very good. Everybody who answered A is absolutely right, because trans alkene is more stable than cis alkene. Okay? Know the stability of alkenes as well. Write this down in your notebook. Trans alkene is more stable. Trans alkene is more stable than cis alkene. This is the stability order. The one which will be more stable will have the minimum heat of hydrogenation, which means it will be more stable molecule. Correct? Yes, very good. Okay, this is all explained over here. Now next is JEE Main 2023 question on your screen. Love this question. JEE Main 2023 question. You've been given a molecule butene. Can everybody see? A butene molecule is given to you. Right? Everybody can see this. And is reacted separately with 1 mole of hydrogen. ठीक है, you are reacting it with hydrogen in presence of two different catalysts. One is palladium and carbon and one is sodium and liquid ammonia. ठीक है, and you are getting two different kinds of products. I know that with the A I will get a cis alkene, है ना, and with the B I will get a trans alkene. Everybody agrees to this? Everybody agrees to this? I will get a cis alkene, here I will get a trans alkene. Now answer the question. A is more soluble than B. The boiling point of melting point of A are higher or lower than B. So which is correct? Which is the correct option? I need to know the answer. Beta, because trans, first of all it fits together very well. It also has a zero dipole moment. There are many reasons behind the stability of trans alkane. It looks like a stable molecule, right? With the cis there is too much charge on it, too much dipole moment, right? So hence it is not that stable. It will show more reactions. Trans is a stable molecule. Now who will answer this? A and B only somebody is answering. A is more soluble than B. How can you say that? How is A more soluble, bachcha? A, okay, remember one thing. A is a cis alkene. Cis means it has a polar molecule. This trans means it is non-polar. Non-polar. Correct? Correct. And A is more soluble than B. Okay. The boiling point and melting point of A are higher and lower than B respectively. Boiling point of A is higher. Correct. A and B. Correct. A option. I've received so many. Very, very good. Very, very good. But the answer is C and D only. Okay, sorry bacha, the incorrect statement was asked. You are right because you identify the correct statements. You bacha are right. I know because I told you the correct. That's why I was looking why the answer is C and D. Because they have asked you to identify the incorrect statements. You are right. I know everybody identified the correct statements. That ma'am, because A is a cis alkene because it is polar. Hence it will be more soluble in polar solvents. Correct. And ma'am, because boiling point of cis will be higher because it is more dipole moment and melting point of trans will be higher. You are correct. You identified the correct statements. You are correct, but the incorrect statements were asked. Okay? So let us not forget to look at the question very, very, good, in a good manner. Okay? Yes, but Tanishka Pandey, you're right. They're asking the incorrect statements. Correct. Chalo, but you got the point. You should understand the question. You understood the question. That was my point. Now let's move on to the halogenation reaction. Okay? Halogenation means what? Now you have alkene with you and you're trying to halogenate it. You're trying to add halogens to it. So there are various ways to add halogen to an alkene. So you took an alkene and you try to react it with this compound, which is a X2 kind of compound, which is a halogen. For example, you took Cl2 or you took F2 or you took Br2, right? So you took an alkene and you're trying to react with the halogen in the presence of the solvent CCl4. What kind of solvent is CCl4? It is a non-polar solvent. ठीक है? Beta, what is the confusion you have, Sandhani? What is the confusion you have? Yes, bacha, the only way to reduce these mistakes is to just please very thoroughly read the question and then only go for answering that question. Okay? And also, one more thing, whenever you are doing the question in your JEE exam, first tick mark the answers in the question paper itself. Do not go and circle the OMR sheet at that point of time. Oh, I know the answer to this, I will circle the OMR. No, wrong approach. Because certain kind of mistakes, silly mistakes are bound to happen. So reread the question 1 or 2 times and then answer that question and fill the OMR at the end. That is my advice to you. Okay? Now next we're talking about halogenation. You took an alkene and you took a halogen atoms just like this, and in presence of CCl4, which is a solvent, what you are getting a vicinal dihalide just like this. Okay, just do not go over here. I will again, one second, I will again write it here. So you took an alkene just like this, R, C, double bond C, here was H, here was H, okay, here was R, and you try to react it with any halogen. Okay, any halogen For example, X2 in the presence of CCl4. Okay, and what is the product you get? You get RCH. Here was the Cl group, and here was the C, and here was the C, here was the Cl group, and this kind of vicinal dihalide you get. Okay, vicinal dihalides you get with X2 and CCl4. Remember this thing. Okay. Acha, there is no OMR, it is CBT based exam. Okay, because in my time there used to be OMR. I'm sorry about that, Kola. Yes, you're right. I'm switching with NEET because I teach both of these classes, right? So what is happening? You get vicinal dihalide, and what is the reactivity order? Once again, it is fluorine is most reactive, then chlorine, then bromine, then iodine. So fluorine will show more violent reaction and will form halogenation reaction. And what is the kind of addition that is happening? I told you that to this double bond, two halogen atoms are attacking. Now understand, if one halogen atoms attack from the above, the other halogen atom will attack from the below. Understand this thing. In this CCl4 solvent, the addition is a anti-addition. Anti-addition is happening just like this. Can you see a compound just like this is formed? So you should know what is the mechanism of these compounds. That is not important. What is important is that an anti-product is formed, but also a little bit about should be known. For example, this was the alkene. I will make you understand it once again. This was the alkene, right? In the alkene, what you're trying to react it with? Br2 molecule, correct? So what will happen? One Br in this case will get a delta negative charge, and one Br will get a delta positive charge. Okay, we just do that. Okay, and what happens? Because this alkene is electron rich. It is electron rich, right? So it will attack the delta positive bromine, and then it will attack and make a bromine atom over here just like this. Can you see? A cyclic structure is formed with the positive bromine here and the negative bromine over here. Okay? Now what happens? This negative bromine leaves, leaving behind the positive bromine molecule over here, and the negative bromine then attacks the opposite side of the carbon, and hence an anti-product is formed with you. An anti-product is formed, and just remove this double bond over here. An anti-addition reaction takes place over here. Understood? Now, bacha, what happened? In that, the solvent that I used was CCl4. Remember this thing. In this halogenation reaction, what I'm doing, I'm adding two. What I'm adding two halogens, one from the below, other from the above. An anti-addition in the presence of CCl4 solvent. But if I change the solvent, I took the same halogen Cl2 molecule, but now the solvent is a water molecule. Now what will be the reaction? So now again, bacha, what happens? Now again the reaction is an anti-product. So to one carbon, the OH will attach, and to the other carbon, the chlorine will attach. And again an anti, it means if the OH will attack from the below, the chlorine will attack from the above. This is again an anti-addition product. So as soon as you change the solvent, the product is changing. With CCl4 on both the carbons, chlorine was getting attached. Now with chlorine in the presence of H2O solvent, on one carbon OH attaches, and on the other carbon chlorine attaches. So please pay attention to what kind of solvent is given to you. As the solvent changes, so the product will change. Only these variations are possible, whatever I'm teaching you here. No other variations are possible ever. Number 4. Beta, what coordination number? This is not a coordination chemistry class. Okay? Now, everybody understood this point? Now, let's move to, these are some important points that you should consider while following any reaction mechanism. Now, let us do this example. At low temperatures, the slow addition of molecular bromine to this gives what? What should be the answer to this question? What should be the answer to this question? At low temperature, you are adding slow addition of molecular bromine. Molecular bromine means what? You are adding to this compound Br2 molecule. So where will the Br2 now attach? Now, where will the Br2 attack? Who can answer this question? Who can answer, please? Just try to answer. There's a double bond also over here. There's a triple bond also here over here. And you're trying to react it with the Br2 with the slow addition. Slow addition. Now, answer me. One answer I got by Jaya Harish was A. Jeevan has answered me B. Omesh has answered me B. ठीक है. Tanishka has again answered me B. ठीक है. ठीक है. Let us look at the answer, which is A. The answer is A. Why is the answer A? Can everybody look at the answer? The answer is A. Why is it A? Can you see that this is an alkyne molecule over here? है ना? This is a triple bond. Always remember the reactivity that alkynes बच्चा are more reactive than alkenes. Number one thing, alkynes are more reactive than alkenes. ठीक है? Now, if they are more reactive, then the Br2 molecule that I was attacking will attack this position, isn't it? So, the Br2 will attack over here, and hence two Brs will attack, one will here and the other Br will attack over here. So, this is the final product. Now, because you are doing a slow addition of the molecular bromine, which means not all the double bonds or triple bonds will get affected, only this will get affected. ठीक है? ठीक है? Everybody understood? Now let's move on to the next question. Let's move on. Understand alkynes are more reactive than alkenes. If you have to choose between them, then the alkynes will react more than alkenes. ठीक है? Next is addition of bromine to 1,3-butadiene gives. This is a different kind of question. I've attached all the possible examples that are there. You can try to solve these questions, but I will tell you how to approach this question. 1,3-butadiene. When I'm trying to add bromine to 1,3-butadiene, what will be the product? What is 1,3-butadiene? It is, this is CH3, this is double bond, this is CH2, this is CH2CH, right? This is 1,3-butadiene, 1,3-butadiene. With 2,1,3-butadiene, you are adding bromine. Now tell me what will be the product. You are adding bromine to 1,3-butadiene. Answer me. What do you think should be the product? In this, you will make use of the reaction mechanism that happens. See, I taught you the reaction mechanism. This is where it comes into play. If you know the reaction mechanism, you will not make the mistake. ठीक है? Now, बच्चा, what will be the reaction? How the Br2 attacks? How the Br2 attacks? See, the Br2 is Br molecule, right? I taught you that one Br will get the delta positive charge, one Br will get the delta negative charge, correct? And to any one of the alkene, for example, this alkene, this Br positive attacks, then what will be the reaction? It will be CH2CH, right? And here the Br will be attacked. Here the positive charge will be there. Here will be the CH, and here it will be the double bond CH2. Correct? This kind of reaction product can be formed. Now before attacking the second negative bromine over here, what else can I do? This positive charge, can you see that this positive charge and this negative charge can interchange its position? Can everybody see that? This positive charge and this alkene can interchange its position because they are in resonance with each other. Can everybody see that? है ना? So now when they interchange this position because they are in resonance with each other, hence the product will be CH2, the Br molecule was already here. Here it will be the C double bond C molecule. Here will be the CH2 molecule. Correct? And here the positive charge will come over here. Right? Now what is happening? The Br negative will attack over here and it will attach over here. So this is the final product that is formed. This is the final product that is formed. ठीक है? So this is a very important kind of reaction where we are making use of the reaction mechanism. So what was happening? We started with the alkene and then I know that one Br gets the delta positive charge, ma'am. The other Br gets a delta negative charge. Correct? Delta positive is first attacked by the double bond. When it got first attacked, the another carbon next to it will get the positive charge. After getting the positive charge, I can see, ma'am, that this double bond and positive charge are in resonance with each other. So I drew their resonating structure and the positive charge went over there. Now I can see, ma'am, that this is a major substituted alkene, hence it is the stable kind of alkene. Hence to this positive charge, the negative bromine will attack. Hence the final product formed will be this. It will be 1,4-dibromobutene. This is the final product that we form. Yes, Sandhani, did you understand the concept? Everybody should understand the concept because same question might not be asked, but similar kind of question can be asked, right? You should know the mechanism. So 1,4-dibromobutene is the answer. Everybody understood? So in organic chemistry, everything is important. If you learned about resonance, that is also important. In every reaction, we are going to include such things in all these things. Correct? So this is, I also explained to you, it is also given over here, the explanation. Now we're talking about hydrohalogenation. Right now what we did, we attacked to the double bond. In the before questions, to the double bond directly two kinds of halogens I was attaching and forming a vicinal dihalide. Right, to the double bond directly I was attaching two halogens. But right now what you're doing, instead of now you're adding one halogen and one hydrogen over here. So what you're adding, you're doing hydrohalogenation. To the double bond, to one portion you're adding hydrogen, to the other portion you're adding halogen. Hence you're doing hydrohalogenation. With which reagent is it possible? It is possible with the HX reagent. Okay, understand this. With the HX reagent, it is possible. It is again a anti-addition. What kind of addition is this? This is anti-addition reaction. What kind of addition? Electrophilic addition, because alkenes show electrophilic addition reactions. So this alkyl halide is formed when I try to react it with HX. Okay, HX means what? Any HCl or HBr acid I can use. Okay, the next is the Markovnikov rule. How is it applied in this position? How is the Markovnikov rule applied? Yes, got it. Very good. Okay, now bacha, what did we do? I took a unsymmetrical alkene. The unsymmetrical alkene that you took is CH3, CH. Just look at the example that I am showing. Here there is a lot of misprinting happening. CH and here it is a CH2. This is a unsymmetrical alkene called as propene. To this propene I have to add HX to it. Okay. Now where will be the H attack and where will the X attack? Now can you see, because I have taken HX over here, which means here it will go away as H plus ion and this will go away as X minus ion, right? Because this is an acid. Acid gives to me H plus ion. So now can you see, this is a double bond over here. Double bond is a electron rich species. This electron rich species will attack the positive thing over here. So the hydrogen will be taken away by this. Okay? So now the possibility is CH3, CH2, CH2. Okay? Now the possibility is to form two kinds of, actually 1 second. Here it is just CH. Now the possibility is to actually form two kinds of carbocations. The carbocation either can be formed on the secondary position or can be formed on the primary position, which means what? The hydrogen, now I attached it to the primary position. The hydrogen got attacked over here, so that the carbocation is formed over here, which is a secondary carbocation. It is more stable, right? So because secondary carbocation is more stable, hence your X minus now attacks the secondary carbocation and the final product that is formed with you is CH3, CHX and CH3 molecule. And this kind of product, bacha, is called the Markovnikov product, where your halogen gets attacked on that carbon where minimum number of hydrogens are present. Can you see here? Minimum number of hydrogens are present on this middle carbon and the halogen gets attacked on that carbon. That is called the Markovnikov rule. Everybody understood this? Okay? ठीक है. Now this is the mechanism that I just taught you about, right? The hydrohalogenation mechanism. Now the formation, also here what is happening? Again, carbocation is forming, and wherever carbocation forms, there is a possibility of rearrangement. So many rearrangements can be possible through this reaction. Now look at here. The major product of the following reaction is, what will be the major product? JEE Main 2024 question. We just discussed it. We just discussed it. To this alkene, you are adding DCl. What is DCl? D is deuterium. It is the isotope of hydrogen, right? So instead of hydrogen, here they have given you deuterium. Now what will be the product of this reaction? JEE Main 2024 question. To which carbon the chlorine will attack and to which carbon the deuterium will attack? Number first. Number second is, what kind of addition is this? Is this a cis addition or is this a trans addition? Who can answer this question? Good afternoon, Connor. I'm looking for answers. First answer I got is D answer. Very good, Ashik. Very good, Ashik. Jeevan has answered C. Bacha, no. The correct answer is given by Ashik already. Beta, yesterday what was the lecture? I didn't take any lecture yesterday. Which lecture are you talking about? C, no bacha, no Connor. This addition is actually a anti-addition. I just told you, this is a anti-addition, number one. Okay? So number one, the major product, they have asked you about the major product. The major is always the trans product. Remember this. The major is always the trans product. So here again the trans product will be major. Let's not write anti over here. Let's write trans over here. The major product is the trans product, right? So what will be the reaction? What will be the reaction? For example, you have taken DCl over here. So first will be that it will give away D plus, right? What will be the first method? It will give away D plus and Cl minus ion, correct? So the D plus number one will attack over here. The D will get attached over here. So the positive charge will come over here. And to this positive charge, this chlorine will attack. Okay? So the correct answer seems to be the D, which is the trans product. Let us look at the correct answer. That is the correct answer. Okay? Hi. Okay? Everybody understood? Should I make you understand that one more time? Do you want to look at the mechanism? If yes, whoever is watching can ask me that right now. Can ask me that right now if you want to look at the mechanism. Now we are going to look at the anti-Markovnikov rule otherwise. Okay? Now the anti-Markovnikov rule is what? Right now. Hi Lithi. Okay. I just told you what is Markovnikov. Markovnikov was कि whenever there is a double bond like this, so if to the lesser to the carbon to which less number of hydrogens are attached, to that carbon the halogen was added, it is called the Markovnikov rule. What is anti? When the halogen is added to that carbon where more number of hydrogens are attached. For example, when I do the same reaction, which is I took the alkene and I took the halo acid, which is the HBr, and I'm trying to react it with in the presence of peroxide. So whenever reactions in presence of peroxides happen, these reactions mostly happen through free radical mechanism, number one thing. Number two, the product that will be formed, bacha, will be the anti-Markovnikov product. Okay, anti-Markovnikov means what? The major product formed will be that the Br is attached over here and the H is attached over here. Can you see this is the major product? The Br is on the last carbon and the H got attacked on this carbon. Okay? So in the presence of peroxide, anti-Markovnikov product is formed, but without the peroxide, Markovnikov product is formed. Just remember these things. This is the mechanism of peroxide mechanism, which I told you is a free radical mechanism. It is a similar mechanism that we discussed previously. You can go through this in the notes. I'm not going to explain it right now because it is not needed. Mechanisms are not asked. Whatever is asked, I'm teaching you. Okay? Now the anti-Markovnikov is, it is interesting to note that the anti-Markovnikov addition in the presence of peroxide is not applicable for HCl and HI. Okay? For HCl and HI it is not applicable because only in presence of HBr that peroxide rule is favorable. Just remember that. If in exam you are given, if in exam it is given to you that some alkene is given to you, right? Some alkene is given and they have given you HCl or HI in presence of peroxide. Okay? If this is given to you, bacha, then the anti-Markovnikov product will not form. The reaction will be through the Markovnikov rule. Markovnikov rule. Remember this thing. Okay? Only and only, okay, this is from the Markovnikov rule. The anti-Markovnikov rule is only applicable for HBr and peroxide. If HBr plus peroxide is given, only and only then the anti-Markovnikov rule will be followed. Remember this thing. Okay? Why? Because both with chlorine and both with iodine, the reaction is actually endothermic reaction. You have to provide energy. Matlab, these are not spontaneous, hence they will not happen. Only with HBr and peroxide you get the anti-Markovnikov product, and with HCl and HI, if you use the peroxide, you do not get the product. Okay? You do not get the product. Okay? Understood? Ma'am, how to get these notes? Beta, I will upload the notes on the Telegram channel. You can join the Telegram channel. The link is in the description box below. Okay? Now again I took this. For example, I took this thing. Now you have to try to react this compound A. You have to form the compound A. This is the compound given to you with 2 double bonds, 2 alkenes in the presence of CCl4. One thing is missing out of this. You are attacking it with plus HBr. Remember this. HBr in presence of CCl4 and high temperature. The compound A formed is. Who can answer this question? Who can answer this question? Who can answer this question? Yes? Can I get any answer? This is again a different kind of question. Yes, we have not read this concept yet, but you can try. So what is happening? You are taking a alkene, there's a cyclohexene, and there's a double bond even upwards over there. And in the presence of HBr and CCl4 at high temperature, you're trying to react it. Then what can be the product? First answer I got by Shreyas is D, by Pravesh is A, by Ashwant is B, and Anurag A. Let's see who all answered the correct answer. The correct answer is B. Wow, Ashwant. I think Ashwant and Connor both gave the correct answer. The correct answer is actually B. Let us look at the mechanism. What is happening? So I told you that another reactant that was missing was HBr. Okay? Now with HBr, what happens? It gives away H plus and Br minus ion, right? So the H plus ion have to attack somewhere. So H plus ion attacks where the positive carbocation formed is the most stable. Can you tell that this carbocation, if the carbocation is formed over here, will be the most stable because this is the tertiary carbocation formed. Hence they have made the carbocation over here. Hence the H attacks over here. So we have added the H. So here I will add, here the H is added and here the carbocation is formed. Okay? Now this bond, again this carbocation is in resonance with this double bond. I always told you whenever it is in resonance, form the resonating product. So the resonating product is formed here now. So after forming the resonating product, the positive charge comes over here. So after the positive charge comes over here, the Br negative attacks this positive charge and this product is formed. Is this thing clear? First of all, with the presence of HBr, what is happening? The H plus goes away and the most stable carbocation is formed, which is the tertiary carbocation. After the tertiary carbocation is formed, now I know that these two are in resonance with each other. So I will definitely form the resonating structure. This is similar as that 1,3-dibutene reaction, right? Again, that product is formed and then again Br attacks this carbocation and this is the major product formed from this reaction. Everybody understood? Chalo, next is JEE Main 2024 question. Very, very good question. Identify product A and B in the following reaction. You have been given an alkene and you have to react that alkene with chlorine in presence of light. We already discussed, right? Alkene in presence of light and alkene in presence of CCl4. What will be the product? Sorry, we didn't discuss in presence of light. I will tell you in presence of light what happens, bacha. With alkene and chlorine in presence of light, a lilac product is formed. A lilac product is formed with CCl4 and Cl2. We have already discussed. So what will be the product A and B? When alkene reacts with chlorine and light, allylic, on the allylic carbon, substitution of chlorine happens. Okay? What is the answer? Sura has answered C. Sura has answered C. One answer I've gotten is C. Hardik Picholia has answered C. Shreyas has answered C. Hardik Picholia now has answered A. Ashwant has answered A. Okay, I've gotten these answers. Let us see who is correct, who is not correct. Let us see who is correct and who is not correct. A is the correct answer. Very, very good to whoever answered A. Hardik, when you change, your previous answer was correct actually. Connor has also answered A. Tanishka has also answered A. Very, very good. So I told you that with the first, what happens? Allylic product is formed with chlorine and light. Allylic positions are, this is the double bond, this position and this position are your allylic position. Remember this thing. Okay? So on the allylic carbon, chlorines are attached. Second is, in the presence of Cl2 and CCl4, what happens? Directly to the double bond it is attached. So directly to the double bond, two chlorine atoms are attached and they have not even asked you the stereochemistry. This was such an easy question, easy peasy question, right? They haven't even asked you the stereochemistry of it. Chalo, next. Among pentene, propene, butene, butanene, which one does not observe the anti-Markovnikov addition of HBr? I told you only in HBr in peroxide, the anti-Markovnikov addition happens. But among these three molecules, I'm going to write them as A, B, C, and D. Which one does not observe the anti-Markovnikov addition of HBr? Who can answer this question for me? Which one? I'm drawing. Before answering this question, you have to draw the molecules. What is pentene? It is 1, 2, 3, 4, 5. This is pentene. This is the A molecule. Correct? Next is propene. Propene is 1, 2, 3. This is propene molecule. Okay? Next is butene. 1, 2, 3, 4. This is butene molecule. This is the C molecule. This is the B molecule and the D is butanene. 1, 2, 3, 4. This is butane. Now tell me, which one of these will not observe the anti-Markovnikov rule? C. I'm getting answer. Ashwant is answered C. C. Hardik Pacholia, C. Ashwant, C. Malvika, Omesh. Everybody is answering C. C is butane. Okay, everybody knows this answer to this. Okay, the solution is obviously the butane because it is a symmetrical alkene, right? The butane, bacha, it is a symmetrical alkene. So no matter where you attack the H, where you attack the Br, it doesn't even matter. They are symmetrical alkene, so it will not show the Markovnikov or anti-Markovnikov. Is same for this product. But here there can be possibilities of additions in all of these cases except in the C product. Correct, correct, correct. ठीक है. You're absolutely right. You're absolutely right. The answer is C, bacha. Is C, bacha. Symmetrical alkenes do not show anti-Markovnikov rule. Understand this. ठीक है. Hi, Jishnu. Hi, Jishnu. ठीक है. Now we're talking about the addition of sulfuric acid. Now to the same alkene, how will you add the sulfuric acid? When you take concentrated H2SO4. What have you taken? Concentrated H2SO4. Then again to the most, this one, towards the Markovnikov rule, I'm again following. Again, I'm following the Markovnikov rule. And here the OSO3H is added. Understand this point. Now with the dilute H2SO4, if I'm using the alkene and I'm instead using dilute H2SO4, what will be the product? The product will be the alcohol. I'm writing it here. The product will be the RCH and here it will be the CH2. So this one will be the product. Okay, don't look at whatever this is drawn over here. This one will be the product with dilute H2SO4, OH group is added. With concentrated H2SO4, OSO3H group is added. ठीक है, ठीक है. And mechanism is again the carbocation mechanism which we've already discussed. What happens? The H plus is attacked by the double bond, है ना? And then the carbocation gets, the more stable carbocation which is secondary carbocation gets formed, and then the OH minus from the water molecule attacks over here, and then such kind of alcohol is formed. ठीक है. Now again in this, as I mentioned, because carbocations, whenever carbocations are formed, bachcha, always remember in such reactions rearrangements is possible. Rearrangement is possible. ठीक है. In such cases rearrangements are possible. ठीक है. Now we're talking about the hydration reactions. Once again, hydrations we've already talked about. We have an alkene in presence of acid and water. What are we adding? On one carbon, the OH is added. On the other carbon, the H is added. Right, this is the hydration of alkene. This again happens with the Markovnikov rule. All of these things are mentioned here. This is a Markovnikov addition. Intermediate is a carbocation. Hence, rearrangement is possible. Rearrangement may take place. So, these remarks are very important. I've already written everything in your slides. These are important notes that you can go through. For example, look at this reaction. Example number 1. You are trying to do, bacha, what? You are trying to do hydration of this alkene. Now, what can happen? What can happen? The H plus will attack this double bond will attack the H plus, right? So the H will get attacked over here, right? And the positive charge will go over here. Now this is a secondary carbocation form. But can you see if I shift this methyl group over here, this can even get converted into a tertiary carbocation, right? So if I move, then what can I do? I am making the molecule once again just CH3, C, CH3. Here again it is CH. Here I will write CH3 once again. The positive charge goes over the tertiary carbocation and here it is a CH3 molecule, right? Now what can happen, bacha? Now what can happen? Now your OH group can, now whatever is the OH group, it will attack this positive charge. Hence the final product formed will be this alcohol. So can you see rearrangements are possible. 1,2-methyl shift, 1,2-hydride shift are possible whenever there is a possibility of the formation of a carbocation. Yes, you are absolutely right, Hardik, that ring expansion is the next example, which is here. Can you see? Can you see? Can you see, Hardik? It is already here. Again, I've taken an alkene. I've taken an alkene over here and I'm trying to react it with H2O and H plus. Right? Now what I'm doing? Now again, this double bond will attack this H plus and the carbocation will be formed over here. Okay? Now can you see this is just a secondary carbocation formed. Now can you see that this is just a cyclobutane, 4-membered ring, not stable. Hence again what can happen, bacha? Again what can happen? Understand that for example this is a box and this is the lid of the box. Right? Right? To convert this 4-membered ring into a 5-membered more stable ring, what will I do? I will open this lid and then I will attack this lid to here. right? Now I'm attaching this lid over here. Okay, everybody is understanding this. Now what can be the next point, bacha? Here, see, they have tried to do similar thing. They've tried to explain it to you in a similar manner. This carbocation is formed. Now this lid will open and it will get attacked to this carbocation. Hence a 5-membered ring and a carbocation is formed over there. Can you see this is again formed as a tertiary carbocation? Right? Now to this tertiary carbocation, the OH2 molecule attacks and hence the final product formed is a 5-membered ring with the OH molecule attached over it. Very easy question. Okay, extremely good. Extremely good. Okay? Now, in the last, I'm going to just leave you with this question. Who can answer this? This is the JEE Main 2023 question. You have been given a reaction like this. Okay? You have been given a reaction where an H plus in the presence of acid you're trying to react. What will be the major product formed? This undergo ring expansion, they have already told you. Then the correct statement of this process is, what will be the correct statement of this process? Bacha, because there is no possibility of formation of 6-membered ring. 1 second, somebody is asking me. Bacha, is there a possibility to form a 6-membered ring now? Is there a possibility? There is no possibility to form a 6-membered ring. Otherwise, obviously, it will form a 6-membered ring, right? There is zero possibility to form a 6-membered ring. Hence, the 6-membered ring is not formed because the positive charge, bacha, comes over here. Can you see that the positive charge comes on the ring itself? Now, where will this charge go? How will you open the ring? There is no possibility. Hence, 5-membered ring. It stops at the 5-membered ring. Correct? Now, this is the question for you guys. I'm giving you this as a homework question. I need to know the answer in the chat box to this. What do you think should be the answer? Jeevan has answered. Okay? Should I leave it here? Should I leave it here? Also, bacha, I have a very important announcement to make for you guys. I will be coming out with a very important series for the organic chemistry. What will it be like? That session will not be live. Those will be recorded sessions where in different videos, I'm going to explain to you the different things. For example, in one video, we're just going to talk about ring expansion. In one video, we're just going to talk about what are the polar protic solvents, what are the polar non-protic solvents. In just one video, we're going to talk about what are electrophilic addition reactions. So just like this, I am creating a playlist already and it will be ready from tomorrow. It will be posted on this channel from tomorrow. One by one, you can access those videos. Those videos will probably range from 15 to 20 minutes, that is it. But the maximum those will be of 15 minutes, right? And we're going to talk about the entire specifically organic chemistry we'll try to cover in them. Because in this 3-4 hour lecture, what happens? These things, these somewhat basic things gets missed out. So to start from the very basic, I've started that series already. I'm working day and night to develop that, correct? So from tomorrow, I will be posting those videos. You can access those videos from the same channel, but they will not be live. They will be recorded session just for your own help. But what can you do to help me for that? Tell me the topics you want to study. Ki ma'am, I have a very major doubt on how to identify aromatic or non-aromatic compounds. I have a major doubt for this. So this is specifically for your JEE April attempt, right? Right? So whatever. Beta, what is your question? Sorry, I didn't read, Tanishka. Can you answer me once again? Can you answer me once again? Can you ask me once again? 1 second. Tanishka, what did you ask? Tanishka, can you ask me the question once again? Okay? So this is a major announcement from my side. I will be uploading that series from tomorrow. Pakka, it will be on the channel. You can access them. Let me know what topics you want to study in the comment section, because this chat I will lose it. As soon as the live ends, I will lose it. I will not know who asked me what query. So in the comment section, let me know, ma'am. Please make a 15-minute video on this, on just this topic. Very, very fixed topic, ki electrophilic addition reactions or ESR reactions. Or ma'am, how to identify the syn products, the anti-products, right? Beta, this is the homework question. This is the homework question, right? Beta, I will give the answer to the homework question in the next session, which is day after tomorrow. I will take your leave now. Okay, I will take your leave now. I will answer this in the, or I will send you the PDF. In that PDF, the answer will be there, because I want you also to take out your pen and paper and try to solve this, because we have studied, or we have studied, right? Like what is the mechanism behind it and whatnot. And please let me know what all topics you want to study before your JEE 2024 attempt. Let me know ki ma'am, in organic chemistry I want to learn about that topic, this topic. Let me know, and I will meet you again day after tomorrow. We're going to start with the haloalkanes and halorenes. Thank you for attending this session. Goodbye. Even CB, write down in the comment section after the live is over, not in the chat box, in the comment, so that I can read it later on. This will go away. I cannot access these chats later on. Okay? In the comment section, syn and anti-compound. Yes, let me know in the chat, not in the chat box, in the comment section after I end the video. Thank you so much. Bye-bye. Pakka, I will make it. I will make it. Thank you, Anurag. Thank you, Jeevan.